Hi everyone, welcome to goclasses. So before we start, please tell me, is the audio video volume, is everything clear? Let me know. So in this session, we will solve a lot of questions on timestamp protocol. Basically, the idea, the content of this lecture is we will see the revision. First of all, what is this timestamp based protocol in the concurrency control? Basically, this is a concurrency control protocol. And so first we will see the revision of this timestamp based protocol, and then we will solve 50 questions on it. Okay. So basically all the variations, all the type of questions we will cover. We will solve all the gate questions on this topic, on this timestamp protocol. All the gate questions we will solve, all the Ullman questions and all the standard questions. So basically a lot of questions we are going to solve in this lecture. Let me tell you that this lecture is basically the revision of timestamp protocol. This timestamp protocol is this is a concurrency control protocol in the transaction management in the DBMS. Okay, so on this protocol, for this protocol, we will do the revision. We will see the summary, all the important points, and also total 50 questions covering each and every important point, covering each and every possible variation. Okay, so let's start this. So let's start the session now. So first we will see the summary of timestamp protocol. Okay. This timestamp protocol we have already seen in our course, in our DBMS course. We have already seen this. So this DBMS complete course. In this complete course, we have already studied timestamp protocol, all the protocols like two-phase locking protocol, timestamp protocol, Thomas Wright rule. All these concepts we have already seen in our DBMS complete course. So this is just a revision and practice. You can see a lot of practice. Okay, so let's start now. So let's see the summary of timestamp protocol. So you know that there are two type of people. Forget about DBMS, forget about this timestamp protocol. In the real life, we have two type of people. There are type 1, I can say there are type 1 people who believe that your actions will decide your fate. Yes or no? So your fate is decided by your actions. This is, some people believe that your actions will decide your fate. And there are some people who believe that your fate is already decided. You are just acting according to it. Yes or no? So there are two type of people in the real life. Do you agree that there are two type of people? So you may have seen, I don't know what type you are, but see, basically there are two type of people. One type, they believe that your actions will decide your fate. Okay, so your fate can change according to the actions. And there are other type of people who believe that your fate is already decided. Your fate is already decided. You are just acting according to it. Now similar thing happens in the concurrency control protocols also. So there are two type of protocols. One is locking protocol, like your two-phase locking protocol. This two-phase locking protocol is, I can say, type 1 people. This two-phase locking protocol, this is type 1 person. It means it believes that your actions will decide your fate. And timestamp protocol, this is type 2 people. This timestamp protocol is based on this idea that your fate is already decided. You are just acting according to it. Okay. So this is our topic, this timestamp protocol. So what this timestamp protocol says? This timestamp protocol says that your fate is already decided. Okay, when you are born. Okay, so when you are born, your fate is already decided. You are just acting according to it. So what I want to say, that the locking protocol, like your two-phase locking protocol, in the two-phase locking protocol, the order of conflicting operations, is determined at the runtime when the transactions are executing. Okay, when the transactions are executing, then this order of conflicting operations is determined in the two-phase locking protocol. So this is the same idea as, basically, your actions will decide your fate. Okay, your actions will decide your destiny. Similarly, there is another protocol. This is time stamp ordering protocol. This protocol believes, this is based on the idea that the order of the serializability order is determined before the transactions execute. Before the transactions are executing, already the serializability order is decided. I know you are not understanding right now, so let me explain this. Let me quickly explain this. See, what this timestamp protocol, I will write it TSP. TSP means timestamp protocol. Okay, it simply means timestamp protocol. Okay, so what this timestamp protocol says, that the order of conflicting operations is pre-decided. This TSP, this timestamp protocol, what it says, it says that in any schedule, whatever schedule you take, in any schedule, remember, in any schedule, whatever schedule you take, in any schedule, the serializability order is pre-decided. This serializability order means what? Serializability order, what that means? Serializability order means your equivalent serial schedules. Serializability order, that means your equivalent serial schedules, correct? Okay, equivalent serial schedule. So the equivalent serial schedule is pre-decided, is already decided. In any schedule, the serializability order is decided in advance, is decided before transactions execute, Okay, so the transactions will execute after, but when the transactions are born, this serializability order is already decided before transactions execute. Okay, so let me explain this little bit more. See what I am saying. I am saying that let's assume that in this TSP, in this timestamp protocol, what happens? Before we see this timestamp protocol, let me tell you what is the difference between timestamp protocol and the locking protocol, your two-phase locking protocol, 2PL. What is the difference between two-phase locking protocol and timestamp protocol? Let me give you the analogy. This analogy I am giving. This analogy, consider this analogy. This timestamp protocol is basically everything is decided when you are born. So when you are born, when transaction is, I can say, when transaction starts. So when the transaction starts means when you are born, then everything is already decided. For example, if the boy happens, then this TSP, like they are like parents. You can consider that this timestamp protocol, they are like parents. You can consider them as parents. Let's assume they are parents. So there are two type of parents. These 2PL, let's assume there are also parents. So you can see that there are two type of parents. Now this TSP, timestamp protocol, these parents, they decide everything when their child is born. Okay, in this TSP, these parents, these TSP parents, they decide everything when their child is born. For example, if it is boy, then it will be then it will become what? If it is boy, then it will become engineer. Okay, if it is girl, then it will become then she will become what? Then she will become a doctor. So you can see that there are this type of parents. These are the TSP parents. Okay, so this is decided when child is born. Child means your transaction. So when the child means your transaction. So when the transaction is born, when child is born, okay, it is decided. Means what it will become. So your fate is decided when you are born. This type of parents are basically TSP, timestamp protocol, these parents. And these two-phase locking protocol, these are advanced. I can say that these are more flexible parents. I can say that these are more flexible parents. These parents are more flexible. They say that, okay, we will see what our child will do, and according to their actions, according to their interest, we will see what they will become. Okay, so I can say basically interest of the child will determine what they will become. Okay, so here I can say interest of child determines their career. Okay, determines their career. So you can see these are the two type of parents. These are the two type of protocols. Did you understand this analogy? I know this is analogy, but don't worry. You will understand what is this timestamp protocol and what is this two-phase locking protocol. The difference you will understand. But this analogy, did you understand that there are two type of parents? Similarly, there are two type of protocols. Okay. So in this timestamp protocol, what happens? Let me tell you. In this timestamp protocol, what happens that it says that if transactions are born like this, let's assume the transactions are coming like this. The transactions arrival. Let's assume the transactions is I can say arrival. The transactions arrival is like this. Let me assume that first this transaction came. Let me assume first this transaction came O, then this transaction came Y. Okay. Let me assume this transaction middle. So very basically I am saying that this is the young transaction because this came last. This is the old transaction. Let's assume these are the transactions. It means this transaction came first, then this transaction came. Let me assume that this transaction came at a time. Let me assume at a time t equal to 0. Okay, this transaction came, let's assume at a time t equal to 1. Okay, this transaction came at a time t equal to 2. So you can see that this is a young transaction, this is an old transaction, and this is a middle transaction. These are the transactions. So basically this is their arrival. Arrival means they are born. They are born in this order. Okay. So transactions are born in this order. This is their I can say birth order. Okay. So this is their birth order. Now what this TSP says, what this protocol says, this protocol says that, okay, so this protocol says that if there is any conflict, see this is old, this is middle, this is young. So what this transaction says, remember this is young, okay, this came last, like this came at time t equal to 2. Okay, so this was born at time t equal to 2. So this was born at time t equal to 2, and you can notice this was born at a time t equal to 0. So this is old transaction, and this is some middle transaction, So what this TSP says, this timestamp protocol, what this protocol says, that all the conflicting operations should be in this order. Okay, what this protocol says, let me tell you. This protocol says that you should not have any conflict in this order. You should not have any conflict from younger to older. See, there should be no conflict. For example, you do read operation here. Okay, this is a conflict operation, right? Yes or no? Can I say this is conflict? Can I call it? Yes, this is conflict because this is read operation, this is write operation, this is read X, this is write X. So this is a conflict. Now what this TSP says, that in this order the conflict is not allowed. So this conflict in this order, the conflict is not allowed. Okay, so in this order the conflict is not allowed. Okay, this order is not allowed. This order of conflict operations. Not allowed. Did you understand what this TSP is saying? This TSP is basically saying, let me tell you, this TSP, this timestamp protocol, this basically says that all the conflicting operations must be in this order. Okay, basically this TSP says that all conflicting operations must be in this order. All conflicting operations must be in the order of transaction timestamp. Okay, means in the order of transaction timestamp. Like this is, you can say this is the timestamp of transaction Y. This is the timestamp of transaction O. So this should happen in the order of transaction timestamp. Means in the order the transactions are born. I can simply say in the order transactions are born. Tell me, did you understand? This is simple rule. Are you getting my point? This TSP, these parents, these are, I can say, they decide everything in advance. They don't care about the actions. These TSP parents, what they say? These parents, they say that whatever be the action, I don't care whatever are the actions. These TSP parents, this protocol, this timestamp protocol, what this protocol says? This protocol says that I don't care in which order transactions, what are the actions of the transactions. I don't care what are the actions. Okay, I don't care what are the actions of the transactions. If they are, if they are born in this order, if they are born in this order, means this is young, okay, and this is old. If they are born in this order, this is the, I can say, this is their born order, this is their birth order. So if they are coming in this order, then all the conflict also should happen in this order. I only allow the conflicts in this order. These type of, this conflict order allowed, this conflict order, this conflict order allowed. Okay, is this clear to everyone? Tell me, did you understand this point? The point is very simple, that this type of the reverse direction conflict is not allowed. So you can see that, for example, some it is writing, and let's assume it is writing. So this is a conflict, and this order not allowed. This conflict is not allowed. So again, you can notice this is a conflict, right? This is a conflict, but remember, this order not allowed. This conflict order not allowed, is not allowed. This conflict order is not allowed. Is this clear? This conflict order is not allowed. Similarly, for example, maybe this is reading, maybe this is reading, this is also conflict, read x, write x, this conflict order not allowed. Maybe you can see, maybe this is writing, this is reading, maybe this is writing, this is reading, this conflict order is also not allowed. Okay, so these are not allowed. These are not allowed. You tell me, a simple question I am asking, is this allowed? Like is this allowed? Tell me. Like wy, write y, is this allowed? Wy, and here you have wx, is this allowed? Tell me. Simple question I am asking, you tell me, is this allowed? Is this allowed? Is this allowed? Tell me. This is not even a conflict. Yes, this is allowed, no problem. Yes, this is allowed, because this is not even a conflict. Please understand that here you are writing y. Okay, this here you are writing y, here you are writing x. So this is not even a conflict. Not even a conflict. This is not even a conflict. So this is allowed. There is no problem. This is not even a conflict. So this is the complete explanation of this TSP. So did you understand this mindset of TSP? Did you understand the mindset of timestamp protocol? This timestamp protocol mindset, did you understand? This TSP, this mindset, what is the mindset there? This mindset, did you understand? This mindset of TSP protocol. Okay, this protocol, did you understand? This protocol is basically saying that, all the conflicting operations must happen in the order of transaction arrival. Okay, all the conflicting operations, remember, very simple, all the conflicting operations must happen in the order of transaction arrival, transaction arrival time. Okay, is this clear? Is this clear to everyone, that all the conflicting operations, this is important, that all the conflicting operations, they must happen in the order of transaction arrival time, Now let me tell you that this transaction arrival time, this is basically called timestamp. Okay, so this transaction arrival time, at what time this was submitted, at what time, this is basically called timestamp. This is basically timestamp of a transaction. What it simply means, let me tell you, it simply means that when a transaction is born, then it is given a timestamp. Okay, so it simply means that when a transaction is born, born means submitted, or I can say created. When a transaction is created, then okay, when a transaction T is born, then T is assigned. What it is assigned? It is assigned a timestamp. A timestamp it is assigned. It is like a birth date. Okay, this timestamp is assigned. So you can see it is assigned a timestamp. This timestamp is similar to the birthday. It is similar to the birth date. Okay, so you can see it is very similar to the birth date, that when a transaction is born, when a transaction is created, then transaction is assigned a timestamp. We assign it a timestamp, and this, of course, this timestamp will always increase. For example, if there is a transaction, let's assume this is the transaction, uh, this is the transaction ti. Let's assume t1 starts. Okay, first transaction t1 starts. Then let's assume this is the time. This is the time that is going on. So you can notice this is the time. This is the time. Now let's assume transaction t1 starts. Then let's assume transaction t3 starts. Then let's assume transaction t3 starts. Then let's assume transaction t2 starts. Okay, so in this order, if they are starting, then what will happen? Then it simply means that in this order, then what will be the timestamp? Let me tell you what will be the timestamp. The timestamp will be like this. The timestamp will be assigned. So remember, so because this is starting first, because transaction T1 is starting first, then this transaction T1 will have some timestamp. Maybe that timestamp can be anything. For example, maybe 50. This transaction T3 will have some timestamp. Of course, it will be more because timestamp always increases. It's like birth date always increases, right? Yes or no? For example, you are born today. If someone will be born after 1 year, then you can see the birth date will be more. The birth date will be more, right? Yes or no? The birth date will be more. So similarly, so this T3 will have some timestamp, maybe 70. Then this T2 will have some timestamp, maybe 100. So you can notice this timestamp always increases. It always increases. It always increases with time, with actual time. It always increases with actual time. Is this clear? So this is simple point, that every transaction when it is born, every transaction when it arrives, when it is submitted to the system, then it is assigned a timestamp. Timestamp is like a birth date. Okay, and what this TSP protocol says, what this timestamp protocol says, this timestamp protocol says that all the conflicting operations must happen in this order. Okay, so you can see that. One more thing I want to tell you. You tell me if there is, if you have timestamp of transaction T1, if it is more than timestamp of transaction T2, then who is older? Tell me who is older? Who is older? Who is older transaction? If transaction T1 timestamp is more than transaction T2 timestamp, then who is older transaction? Which transaction is older? So you can clearly see that timestamp will always increase. It means this is younger. It means this is younger transaction. Okay, and this is definitely older transaction, right? Because it's like birth date. It's like birth date. So if this birth date is less than this birth date, then definitely this is a younger transaction and this is an older transaction. So here T2 will be the older transaction. Okay, so very simple point I want to tell you. This is a note. What is the note? That so if basically if you have timestamp of transaction T, if that is less than timestamp of transaction T dash, then in this situation what we will say? Then in this situation, remember, this T will be the older transaction. This will be the older transaction, and this will be the younger transaction, and this will be the younger transaction. Okay, and if this is older transaction, this is younger transaction, then what TSP says, what timestamp protocol says? So what this TSP timestamp protocol says, this TSP says that if timestamp of T is less than timestamp of T dash, means this is basically, then what this TSP says, this TSP says that all the conflicting operations, remember, all the conflicting operations will happen in this order. So the conflicting operations can only happen in this order. Very simple. So if there is any conflicting operation can only happen in this order. Okay, means first this will happen, then this will happen. So here the time is increasing. Here the actual time is increasing. So you can see that conflicting operations will happen in this order. So this will be the order of conflicting operations. This will be the order of conflicting operations. This will be the order of conflicting operations. Similarly, okay, in this order the time is going. So in this order it is not allowed. Like this type of order, this type of conflict order is not allowed. Okay, so this type of not allowed. So if this type of conflict, this type of conflict order is not allowed. So this is a simple concept. I hope you understood this concept. So everything is predetermined. Basically this TSP, everything is predetermined that in this order conflicts should happen, in the order of their arrival. Now let me tell you a small difference between this TSP versus 2PL protocol. This timestamp protocol versus 2PL protocol. A simple scenario I am giving. A simple, very simple scenario I am giving. First, let me give you the analogy. Let me give you the analogy. The analogy is like this. The analogy is like this. In the TSP, a simple thing cannot happen. See, in the TSP, in the timestamp protocol, this type of simple thing also not allowed. Like this is a boy, this is a girl. Okay, so let's assume these are the parents, these are the TSP parents. So in the TSP, this type of simple thing is also not allowed. So you can see, for example, boy becomes doctor. Okay, or maybe so boy becomes doctor and maybe girl becomes air hostess. So this type of thing is also not allowed. Okay, so you can see this is also not allowed. Are you getting my point? The analogy, I'm just telling you that this type of simple thing is also not allowed. Not allowed. But in this 2PL, it is allowed. In this 2PL, this situation will be allowed. In this 2PL, this situation will be allowed. So this is just an analogy. Now let me give you actual scenario. Like consider this transaction. Let me assume there is a transaction. There is a transaction T, there is a transaction T dash. You have two transactions. And let me assume this is the order. Means this is the older transaction. This is the older transaction. And this is a younger transaction. Okay. Now this is an older transaction. This is a younger transaction. Now you can see that this type of simple, a simple question I am asking, very simple question I am asking. Let's assume it is writing some item X. It is reading some item X. Is it allowed by 2PL? This schedule, is it allowed by 2PL? Simple question I am asking. Very simple question I am asking. Is this allowed by 2PL? Is this schedule, look at this schedule, is this schedule allowed by 2PL? Is this schedule allowed by 2PL? Is this simple schedule allowed by 2PL? Tell me. A very simple schedule that is given to you, is this simple schedule allowed by 2PL? Is this schedule allowed by 2PL? The answer will be yes. The answer will be yes. It is simply allowed by 2PL, right? Because what you can do? Is it allowed by 2PL? The answer will be yes. The answer is going to be yes. Because what you can do, you can just simply take the exclusive lock. You can take the exclusive lock, right? So here you can take a request for the exclusive lock on X. Then you can unlock this X. And then you can take a shared lock on X. And then you can unlock X. So this is definitely allowed in the 2PL, right? Correct? This schedule is definitely allowed in the 2PL because you can request exclusive lock on X. Then you can perform this write X. Then you can unlock X. Similarly, then this T can take shared lock on X, then it can perform read X, then it can unlock X. So this schedule is definitely allowed by 2PL, but you can notice, is this allowed by TSP? Is this allowed by TSP? A simple question. Is this allowed by 2PL? TSP. Is this schedule allowed by TSP? By timestamp protocol? Will the timestamp protocol allow this schedule? The answer is clearly no, because you can notice that this is a conflict, and the conflict in this order the conflict should not happen. You can see that in this order the conflict should happen in this order. So you can notice this is a conflict. This is a conflict and this is not allowed. So this conflict order not allowed is not allowed. So this conflict order, you can easily see that this is not allowed. Is this clear? Please tell me. Let me know, is this clear to everyone that this conflict, this simple example is giving you everything. Like this simple transaction, this simple schedule is allowed by 2PL, but it is not allowed by TSP. So can I say this TSP has a predetermined mentality, right? Yes or no? This TSP, what is this TSP and 2PL? What is the difference between TSP and 2PL? It determines, okay, it determines It determines order of conflicts. Order of conflicts at runtime, right? Yes or no? At runtime it will determine. At runtime it will determine. It is very flexible. At runtime it will determine. Okay, so this 2PL, this two-phase locking protocol, it will determine order of conflicts. This order of conflicts, it will determine at the runtime, right? Yes or no? But in this TSP, this has a predetermined mentality. So it predetermines order of conflicts. Order of conflicts. It predetermines order of conflicts. Okay, so this is something, the difference between 2PL and TSP. This timestamp protocol and 2PL. This is the difference. So it will determine at runtime. This 2PL, it will determine at runtime. At runtime it will determine. But you can notice this TSP will predetermine the order of conflicts. So this is very simple explanation of a timestamp protocol. So what this timestamp protocol says, it says that your fate means serializability order is already decided in the order you are born. In the order you are born, you just need to stick to it. Okay, in the order you are born, it is already decided. Similarly, for example, so you can see serializability order is decided in advance. When you are born, your serializability order is already decided. A very simple scenario. So all you have to remember that in the timestamp protocol, this is the simple rule. What is the timestamp protocol rule? Let me tell you. Only simple rule. There is no other rule, only simple rule. What is the simple rule of timestamp protocol? One simple rule of timestamp protocol, that if the transactions are, if this is the order of transactions, like let's assume timestamp of transaction T is less than timestamp of transaction T dash. Okay, it means then this TSP, what it says, then order of conflict operations. What should be the order of conflict operations in any schedule? In any schedule, the order of conflict operations in any schedule. Okay, so these are the two transactions, transaction T, transaction T dash. Then the answer is that order of conflict operations, okay, in any schedule between T comma T dash, what, okay, should be in the order, must be in the order of T then T dash. Okay, should be in this order. Very simple. So this is a simple thing, that this is your T, this is your T dash. So whatever conflict operation you take, this should be the order of conflict operations. Remember, this is the actual time that is going on. This is the actual time that is going on, and this should be the order of conflicts. This is the order of conflicts. Okay, very simple. So that's it. Now let's move on. So this is the rule. You can read this rule. So serializability order is decided in advance. Your serializability order, the serial schedule, tell me in the TSP, what is the equivalent serial schedule? Like, this is a simple question I am giving you, that there is a TSP, timestamp protocol scheduler is there. Okay, this scheduler is there. Let's assume. And also let me assume that there are three transactions. You have three transactions. One is older, then one is middle, then one is younger. And I am saying the timestamp of older is less than timestamp of middle is less than timestamp of younger. Means this Y is basically the younger. This Y is basically the younger. Okay. Now there is a schedule. Now what will be the serializability order? If you create this TSP allows some schedule. Let's assume this TSP allows a schedule of O, M, Y. Okay. So this TSP allows a schedule of O, M, Y. Then what is the serializability order? Then what is equivalent serial schedule? Tell me, what is equivalent serial schedule? What is the equivalent serial schedule? So there is some schedule S, you have some schedule S, and I'm saying that what is equivalent serial schedule? What is equivalent serial schedule? Tell me. The answer is going to be, this is the equivalent serial schedule, O, then M, then Y. Okay, this is what I'm saying. So everything is predetermined. Tell me. A simple question I'm asking. A simple question that, do you care about the actions of O, M, Y? Do you care about what O will do, what M will do, what Y will do? Do you care about it? No, we don't care. Okay, so it's like this. When a child is born, you decide that if it is boy, it will become he will become engineer. If it is if she is a girl, then she will become doctor. So you don't care what is their interest. Okay, you don't care what they will do in the future. You have predetermined their, I can say, their career. You have predetermined. This is what TSP does. This is what timestamp protocol does. Okay, timestamp protocol does this. Timestamp protocol determines the serializability order in advance. Okay, so serializability order, it is determined in advance by timestamp protocol. A simple rule. What is a simple rule? That in any schedule, whatever schedule you create, the order of two conflicting operations should be in the order of their transaction timestamp. This statement, this line, understood? This line is understood, right? In any schedule, whatever schedule you take, the order of two conflicting operations should be in the order of their transaction timestamp. Okay, very simple. If it is not, then what? If not, then what? For example, if this happens, by the way, let's assume that this transaction T dash, and if, by the way, if this happens, that in this order, if things happen, like, remember, this is the time that is going on. In this order, time is going on. So let's assume this write happens first, then after some time this read happens. Now what? Now what? Are you getting my point? I am simply saying that this is a conflict. This is a conflict. This is a conflict. And the transaction T is older. The transaction T is older because you can notice this transaction T has more timestamp, higher timestamp. This has higher timestamp. Okay. Now, if this happens, then what? If this happens, then what? Let me tell you a simple rule. What is the simple rule? If you are late, it is your fault. Is this clear? If you are late, this is a simple rule that if you are late, it is your fault. So if your turn is gone, it is your fault. If you are late, it is your fault. And if it is your fault, this TSP says that, if it is your fault, then abort. If it is your fault, then abort. So whose fault it is? Tell me. The person who is late. Yes or no? If you are late, then it is your fault. This is a simple rule. If you are late, it is your fault. And if it is your fault, then you abort. Then you will abort. So this is what I am saying. Simple that. In this, tell me who is late. Remember, this is the time. Time is going in this direction. In this direction, time is going. So definitely this T is late, right? Yes or no? This T is late. Here I can say T is basically late. This transaction T is basically late. So T rollbacks. So T aborts. Okay. So here what will happen? Basically, we can't allow this. This conflict order we can't allow. Remember, very simple point that this order not allowed. This conflict order not allowed. This conflict order not allowed. We cannot allow this conflict order. This is not allowed. So who is late? T is late. So T will roll back. Very simple. Okay. So because this operation is already done. Remember, very simple point. This operation is already over. This operation is already over. Now, when this operation happens, then here the T will abort. Okay, here the T aborts. Tell me, will this operation happen? T is aborting. I am simple question I am asking. Will this operation happen? Will this operation happen? No, this operation will not happen because we will decide that, okay, this operation cannot happen. Okay, this operation cannot happen, so T aborts. So this operation will not happen. Remember, this operation will not happen. This is unsuccessful. This is unsuccessful. Okay, this is unsuccessful. So this operation will not happen. This is unsuccessful. This operation is unsuccessful. So very simple. So I hope all the points are clear. Now let's move on. So this is what I am saying, that see, read this paragraph. If you understand, then you have understood timestamp protocol. This is a very simple protocol, let me tell you. If you are not understanding, then okay, just focus on this line and don't worry about it. By the end of this lecture, you will become expert of this protocol. I promise you, you will become expert of this protocol. You will be able to handle any variation, any question, any standard question, gate question, whatever, any proof. You can also prove things. So let's see this. In any schedule, the order of conflict operations should be determined. Whatever schedule you take, the order of two conflicting operations should be in the order of their transaction timestamp. This is the first thing. If not in this order, then the transaction which is late is aborted. In this order, if in this not in this order, then the transaction which is late is aborted and restarted with a new fresh timestamp. Okay, and restarted with a new fresh timestamp. We will start it with a new fresh timestamp. Okay, this is the complete situation. So if you are late, it is your fault. Simple. Now now we will see a lot of questions. 50 questions we are going to solve. But before that, one thing I want to tell you, that what this timestamp protocol does. This timestamp protocol implementation. This implementation, how the implementation happens. Let me just simply tell you this implementation I am telling you. The idea you understood. The timestamp protocol idea you have understood. Now let's see how the implementation will happen. This implementation, how to implement this. So to implement this, what we do, for every data item, also we define. Remember, for every transaction we have timestamp, but for every data item X, if you have any data item X, we have something called, read timestamp. What we define? We define read timestamp. This read timestamp we define. Read timestamp of X. We will call it RTS, read timestamp of X. We also define write timestamp of X. We also define, means for every item, for every element, we define write timestamp and what is read timestamp. And what are these? Let me tell you. These are basically who is the youngest transaction who did the read operation and who is the youngest transaction who did the write operation. Okay, so you can see the definition here. What is the read timestamp of X? See this. Read timestamp of X. For any database element X, we have two timestamp. Okay, we have two timestamp. So what is the read timestamp of X? The read timestamp of X is basically the highest timestamp of transaction which is reading X. Which is the youngest transaction who is reading X. Basically, youngest transaction reading X. Basically, who is the youngest transaction? Who is the youngest transaction reading X? Who is the youngest transaction reading X? Similarly, what is write timestamp of X? That is, what is the highest timestamp of transaction that is writing X? Means who is the youngest transaction? Who is the youngest transaction writing X? Who is the youngest transaction writing X? So very simple. So this is the concept. For every item, for every data element, we define these. So let me take example. With example, you tell me. Assume that there are three transactions. Again, I am saying that you have three transactions. Let's assume that you have total three transactions are there. I am giving you three transactions, T1, T2, T3. Okay. Let me assume that timestamp of T3 is less than timestamp of T1 is less than timestamp of T2. This is what I am saying. Okay, what I am saying that timestamp of T3, this timestamp of T3 is less than timestamp of T1, less than timestamp of T2. So you can see this is the youngest, right? Correct. This is the youngest. If you notice, this is the oldest. So this T3 is the oldest, T2 is the youngest, and T1 is middle. Now you consider some questions, like I'm giving you T1, T2, T3. You tell me, like, let's assume this is reading X. You tell me all the answers that I'm asking. For example, let's assume this is reading X. this is reading x, this is reading x, this is reading x, and this is reading x. Or maybe, yeah. Okay, so you tell me what is the timestamp of x at this point of time, at this point of time. You tell me at this point of time, what is the read timestamp of x? What is that? At this point of time, what is the read timestamp of x? Remember this, please keep this in mind that you have three transactions, T1, T2, T3, where T3 is the oldest, T2 is the youngest, and T1 is some kind of middle. So you tell me, this you keep in mind that T3 timestamp is less than T1 timestamp is less than T2 timestamp. Now simple question I am asking that if these operations are happening, then what is the read timestamp of x here? For this element x, you have this element x read timestamp. So remember, read timestamp will be what? Who is the youngest transaction who did the read operation? The answer will be T2. Remember, this T2 is the youngest transaction to do the read operation. Okay, so don't see this like, are you getting my point? Don't I'm not saying that the actual time, see that the time is going like this, the actual time is going like this. I am saying who is the youngest transaction. I am saying who is the youngest transaction who did the read operation. So remember, this is the youngest transaction. Because of this, so I can say the answer will be T2, because this T2 is the youngest transaction to do the read operation. This is the youngest transaction to read x. This is the youngest transaction to read x. Clear? Is this clear to everyone? Ekta, is this clear? Answer will not be T3, answer will be T2, because T2 is the youngest. This is the order T3, T1, T2. So the answer will be T2. Now let me tell me another question I am asking. For example, let's assume this is read, this does the read operation, this does the read operation, then this does the read operation. Now you tell me what is the read timestamp of x. Again I am asking read timestamp of x. What that will be? Read timestamp of x. What is that? Who is the youngest who did the read operation? So you can notice the answer will be T1. This T1 is the youngest to do the read operation. Okay, this T1 is going to be this T1 is the youngest. This is the youngest transaction, or I can say to do read operation, to do read x. Okay, so this is the youngest transaction to do the read x. Very simple. Okay, tell me the answer for this question. If this does not happen, now the answer will be what? Now the answer is going to be what? Now the answer will be what? Now in this situation the answer will be what? Answer will still be T1. Answer is still going to be the T1. Okay, in this question also the answer is still going to be the T1, because T1 is the youngest to do the read operation. I hope this point is clear. Very simple point. Tell me another question I am asking. For example, let's assume this T1 does the write operation. This does the write operation. This does the write operation. This does the write operation. Okay, some schedule I am giving you. Now you tell me what is the okay, now in this situation, what is the write timestamp of x? Tell me, what will be the write timestamp of x? What is going to be the write timestamp of x? The answer again will be T2, because again T2 is the youngest. T2 is the youngest. You can notice T2 is the youngest, or I can just simply say that T2 is the youngest to perform the write operation. Now let me tell you a simple thing, that actually this schedule will not be allowed. Actually what will happen, let me tell you, because you know, see, will this schedule be allowed? Simple question I am asking, is this schedule allowed? Is this schedule allowed by timestamp protocol? Is this schedule allowed by timestamp protocol? Tell me. Is this schedule allowed by timestamp protocol? And the answer is no, because what is happening, see, first of all, the best way is you always write in the timestamp order. First of all, this is the timestamp order. You always write transactions, the schedule you always write in this order. Are you getting my point? What I'm saying? See, this is confusing, right? Do you agree that this is confusing, because T3 is oldest, T2 is youngest? So do you agree that this is confusing? Do you agree with me that this is confusing? So what you can do, for simplicity, you can just put them in this order: T3, then T1, then T2. In this order, you can put them. This is the youngest. Or I can say this is the highest timestamp. This has highest timestamp. This has highest timestamp. Okay. Now in this order you put them. Now you can see that. Remember the time was going on this in this direction. Remember the time. The actual time was going in this direction. So it means first T1 was doing the right operation. First this was doing the right operation. Then this T2 was doing the right operation. And this T3, then this T3 was doing the right operation. Is this allowed by 2PL? TSP? Is this allowed? This is fine, right? This is fine. There is no problem here. This is fine. But this is not fine. Right? Yes or no? This conflict order not allowed. You can notice this conflict order not allowed. We do not allow this conflict order because the conflict order should be like this. This is the conflict order. This is the conflict order. This is the conflict order. So this conflict order is not allowed. Who is late? Tell me who will abort? Who is going to abort? Simple question. This conflict order not allowed. So who is going to abort? So you can easily see that at this point of time, T3 aborts. Because T3 is late. So at this point of time, T3 aborts. So T3 will abort. Remember, this is unsuccessful. This operation will be unsuccessful. This operation does not happen. So this operation is basically unsuccessful. So this operation actually will not happen. Ultimately, the right timestamp of X will be only T2. The right timestamp of X, that will be T2. So you can easily see that if I ask you what is the right timestamp of X, that will still be T2. Okay, because this is unsuccessful operation. So don't consider the unsuccessful operation. When you have this read and write timestamp, when you determine this, then don't consider the unsuccessful. So remember, unsuccessful transactions you don't consider. So is this clear to everyone? What is for any element? Did you understand what is read timestamp and write timestamp? So very simple definition. You can see the definition. The read timestamp of X is the highest timestamp of the transaction. Okay. This read timestamp of X, what is that? That is the highest timestamp of a transaction. Highest timestamp of a transaction. Who is doing the read operation? Who is doing the read operation? And the write timestamp of X is the highest timestamp of a transaction that is doing the write operation. So very simple. This is how we do the implementation of TSP, timestamp protocol. This is how we do the implementation. Now are you ready for 50 questions? Actually not 50, actually almost 60 questions I have taken. Are you ready for all these questions? Can you take your copy pen? Because I want correct answers from you. For every question, for each question, you should give me correct answer. Okay, total 50 questions back to back I am going to ask you. Okay, just take your copy pen, keep your copy pen with you. Okay, and then you answer all these questions. Now let's start. Shall we start? Please tell me. Give me yes or no. Are you ready to solve all these questions yourself? You will solve them yourself. I am going to ask them back to back. Okay, and by the end of this lecture, you will become expert. You will become, I can say, like a professor of this timestamp protocol. So let's see the first question, the question number 1. Let's see this question. First of all, let me give you some context. In all these questions, I'm assuming in all these questions, what I'm assuming, I'm assuming 3 transactions. One is Y, another is M, another is O. I'm saying that Y is the youngest transaction. Okay, this Y is the youngest transaction. It means it has the highest timestamp. O is the oldest transaction. It means it has the lowest timestamp. And M is some middle-aged transaction. Okay, so this is the assumption. Now you solve this question. Tell me the answer for this one. Is the following allowed or not in the timestamp protocol? Simple question. Question number 1. Is this allowed in the timestamp protocol or not? Remember, this is transaction. Remember, this is a transaction. This is transaction. Transaction Y reads data item X. Then at any later point of time, this transaction M writes item X. Is this allowed? Is this allowed or not? Tell me. Simple question I'm asking. Is this allowed or not? The transaction Y is reading data item X. Okay, if you are confused, then always draw the chart. Always, if you are confused, always draw the chart. So what is the chart? You know that Y is youngest. There is Y, there is O, there is M. These are the transactions. Okay, these are the transactions. Always draw the chart. Okay, don't give me wrong answer. Always draw the chart. Y is reading data item X. So this Y is reading data item X. It is reading data item X. Then at some later point of time, after some point of time, M writes item X. After some point of time, maybe, okay, after some point of time, M writes item X. Is this allowed? Basically, the time is going like this. The actual time is going like this. So first this operation is happening. Maybe this operation is happening at time t equal to 2, and maybe this operation is happening at time t equal to 13. Okay, so the time is going like this. Is this allowed? Tell me. A simple question. So the answer is no. This type of ordering is not allowed. This conflict order is not allowed, right? Yes or no? Because you can notice the TSP, the timestamp protocol says that in this order, this is the conflict order. Remember, this is the conflict order. This is the conflict order. So this is the serializability order. So this is definitely not allowed. So who will tell me what will happen then? If it is not allowed, then what will happen here? Who will roll back? Who is going to roll back? So here I can say this M rollbacks. Okay, so here I can say that M rollbacks. M will roll back and it will restart. Remember this O, M, Y. This is reading X. This is writing X after some point of time. This is not allowed. So here what will happen? This is unsuccessful. First of all, this is unsuccessful. Okay, this is unsuccessful. Here I can say M, at this point of time, I can say that M rollbacks and restarts. Okay, M will restart with which timestamp? M restarts with which timestamp? With its original timestamp? With its original timestamp or a new timestamp? Simple question I am asking. M will restart with the original timestamp, with the old timestamp, or with the new timestamp? The answer will be with the new timestamp. With the new timestamp. Why? This I will answer after some time. Okay. Now you might be thinking why? Like, see, this will happen, but why? With the new timestamp, you might be thinking why, right? Is there anyone who is thinking why? Why new timestamp? Why not the old timestamp? See, the M will roll back. M will restart with new timestamp. Why not with old timestamp? What is the reason it will not start with old timestamp? This I will tell you after some time. Okay, don't worry. This we will see. We will see. I will give you the proof. I will give you the proof. Don't worry. That we will see. But anyway, it will restart with a new timestamp. A new timestamp it will start. Okay. So anyway, so this is your question. So this is not allowed. You can see the answer will be not allowed. So for this question, the answer will be not allowed. Now let's move on to the next question. Tell me the answer for this one. Question number 2. Tell me the question number 2. Is the following allowed or not allowed in the TSP, in the timestamp protocol? M reads, this is a transaction. This is a transaction. So this transaction reads data item X. It is reading data item X. Then at some later point of time, Y is writing item X. If you are confused, always draw the chart. Okay, so there are 3 transactions: old, middle, young. This is the order. You can see that this is the order of conflicts. This is the serializability order. This is the serializability order. Now the question is saying that M is reading item X. It is reading item X. Then after some point of time, it is writing item X. So there is no problem, right? Yes or no? It is fine. This order of conflict is fine. Correct? This conflict order is fine. This conflict order is fine. So definitely this is allowed, I can say. Right? Yes or no? So this will be allowed. This is going to be allowed. Very simple, because this conflict order is fine. We don't have any problem with this conflict order. The timestamp protocol says that conflict order should be in the order of their timestamp. You can notice the timestamp order is also this, and this order is also this. So this is the timestamp order. This is the timestamp order of transactions. This is the timestamp order of transactions, and you can see that this is the conflict order, and they are same, right? They are same. So the conflict order is same as the timestamp order of the transactions. So this is allowed. What about this question? Question number 3. Tell me the answer for question number 3. Is this allowed or not? Another simple question. Transaction. Remember, this is transaction. This is a transaction. This is the oldest transaction. So this is a transaction. Transaction O reads data item X. Then at any later point of time, transaction Y writes item X. Tell me, is this allowed? The answer will be again allowed, because this is fine. There is no problem. This is old. This is middle. This is so it is reading item X. Then after some point of time, this conflict order is fine. Yes or no? This is perfectly fine. This is perfectly fine. Okay, there is no problem. So this is allowed. What about this one? What about this question? If you have any doubt in any question, you can tell me. I will answer it. So don't keep any doubt. Make sure that you become expert. Make sure that this timestamp protocol becomes so easy that even after 2 years, 3 years, even after 10 years also, if anyone asks you timestamp protocol, you can answer it. This is the purpose of this lecture. I want you to understand timestamp protocol so nicely that after 10 years also, if someone asks you what is timestamp protocol, you can explain. Okay, whatever question, whatever variation comes in the GATE exam, you can handle it. So you tell me the answer for this question. The transaction M is reading item X, then at any later point of time, O is writing item X. This is definitely not allowed. Yes or no? This is definitely not allowed, because you can easily see what the question is saying. The question is saying that there is O, there is M, there is a transaction Y. This is the timestamp order. So you can see that now the question is saying that M is reading data item X, and then at any later point of time, O is writing data item X. So this order, this is definitely not allowed. This is the conflict order. This conflict order is not allowed. So we don't allow this conflict order. So at this point of time, what will happen? This will become unsuccessful. First of all, this will become unsuccessful. This operation will not happen. Remember, this operation will not happen. And at this point of time, I can say that at this point of time, this transaction O aborts. It aborts and restarts with new or old timestamp, and restarts with a new or old timestamp, with a new timestamp. Why? We will see after some time. Don't worry. With a new timestamp, it will restart with a new timestamp. What is the reason? We will see after some time. Okay, let's see this question. Is this allowed or not? So the young transaction is writing data item X. Then at any later point of time, M is writing data item X. So again, this is not allowed. Correct? This order is not allowed. Very simple. Okay. Now let's see the next question. Tell me the answer for this one. Question number 6. O is writing data item X. Then at any later point of time, M is writing data item X. This is fine. There is no problem, because you can see this is transaction O, M, Y. So it is writing item X. After some point of time, it is writing item X. This is perfectly fine. There is no problem. This conflict order is perfectly fine. So this is allowed. Okay. Now, what about this question number 7? Quickly. Is this allowed or not? Transaction Y writes item X. Then at any later point of time, O writes item X. This is definitely not allowed. Okay. So this is your O, M, Y. This is writing item X. And after some point of time, it is writing item X. This is definitely not allowed. This is a conflict. This is a conflict, and hence this is not allowed. What about this question? So here M is writing data item X, sorry, O is writing data item X. After some time, Y is writing item X. This is allowed. There is no problem here. Okay. In this, there is no problem. So like this, you can easily solve this question also. Question number 9. O is writing item X. O is writing data item X. This transaction O that is writing data item X. After some point of time, Y is reading item X. It is writing item X. After some point of time, it is reading item X. This is also conflict. But this conflict is fine, right? Yes or no? This is allowed because old, middle, young. So you can notice this is writing item X. After some point of time, this is a conflict, but this conflict is allowed. This is reading item X. You can see this is a conflict. This is a conflict, but this is fine. This conflict order fine. Okay, so there is no problem. So here this will be allowed. What about this question? Tell me quickly the answer. What is the answer here? Question number 10. Transaction Y is writing data item X. It is writing data item X. And then this O is reading. See, this is also conflict, right? This is writing item X. Then this is like, this is your O, M, Y. So this is writing item X. And after some point of time, this is reading item X. So this is a conflict. You can easily see this is a conflict. Read, comma, write, write, comma, read. So this is a conflict and this is not allowed. This order of this conflict order is not allowed. Okay, so this is definitely not allowed. What about this question? Tell me. What about this one? Transaction M is writing item X and then some point of time Y is writing reading item X. Okay, so again this is fine. There is no problem here. This because this is the transaction M. So it is writing item X. Then after some point of time it is reading item X. This conflict order is fine. There is no problem. Okay, so this is allowed. So like these are the questions. All the variations I am covering actually. That is the reason. See, similar questions, all these. But now some nice questions are coming. Don't worry. Like this is the final question. So tell me, M is writing item X. Then O is reading item X. So this is not allowed, right? Because you can notice O, M, Y. M is writing item X. Then after some point of time, O is reading item X. This is not allowed. Correct? This is definitely not allowed. So here the answer will be not. Okay. And what about this one? What about this one? M is reading item X and then at any later point of time O is reading item X. Is this allowed? Is this allowed or not? Question number 13. Tell me the answer for question number 13. What is the answer for question number 13? M is reading item X. Then so this O, M, Y. M is reading item X. After some point of time, O is reading item X. Is this allowed or not? See, this is allowed because this is not even a conflict. This is not even a conflict. Please understand that this is not conflict. This is not conflict pair. Read is not a conflict. Okay, please understand this read is not a conflict. This is reading, this is reading. Read is not a conflict. So this is allowed. So there is no problem here. This is allowed because this is not even a conflict. That is the reason this is allowed. Okay, what is the answer for this one? For this question, O is reading, M is reading. No problem. This is not even a conflict. This is allowed. This is not even a conflict. There is no conflict here. So this is, I can say this is not even a conflict pair. This is not even a conflict pair. So this is allowed. Similarly, this is also like Y is reading. Y is reading, O is reading. So there is no problem. This is also allowed because this is not a conflict. Okay, as long as there is no conflict. So these are the questions done. So far the questions that we have seen, these are just to check your understanding of what is allowed, what is not allowed. So okay, in these 15 questions, are you comfortable with the question number 1 to 15? Question number 1 to 15, are you comfortable? Are you comfortable with question number 1 to 15? Tell me. Did you understand what is allowed, what is not allowed in the timestamp protocol? Let me know. Yes or no? So if you are watching this video as a recorded video, if any student is watching this video not live but as a recorded lecture, then please comment. Okay. Comment and like. Now let's move on. Now let's see question number 16. Question number 16. Please tell me the answer for this one. In a schedule, there is a schedule that is generated. In a schedule that is generated allowed by timestamp protocol, there is a schedule which is generated by a timestamp protocol. Assume that transaction T reads item X. At some later point of time, transaction G writes item X. What can you say about timestamp of T, G? Did you understand the question? Question is very simple. Question is saying that, read the question carefully. There is a schedule which is generated, which is allowed by timestamp protocol. So a schedule is already allowed by timestamp protocol. Assume that transaction T reads item X. At some later point of time, transaction G writes item X. What you can say about timestamp of T, G? Okay, so are you understanding? The question is saying that there is a transaction TSP, timestamp protocol allows a schedule S. There is a schedule S. Okay, so in this schedule S, what happens? In this schedule S, this happens that there is a transaction G, there is transaction T, G, and the transaction T reads item X. Then G, after some point of time, G writes item X. So what can you say about timestamp of T, G? The answer will be what? You can easily see that if this is happening, the time is going like this. The time is going like this. So you can easily see that in this order, if the things are happening, then their order also must be same. So I can say this can never happen, right? That T is greater than G. This can never happen. Do you agree? Do you agree that this can never happen? I can say that either T is same as G or T is less than or equal to G. Okay? Either T can be same as G. Remember, one more thing I want to tell you. Two different transactions never have same timestamp. Okay? Two different transactions can never have same timestamp. Timestamp is something, this is always increasing. This is something always increasing. Okay, timestamp, that is something that is always increasing. So two can never have timestamp. For example, this is a question. Let's assume there are two transactions. There is transaction T1, there is transaction T2. If timestamp of transaction T1 is equal to timestamp of transaction T2, what can you say? Then what can you say? Tell me then what you can say. Simple question I am asking. Then what you can say? If they have same transaction timestamp, then what you can say? Then the answer will be T1 is same as T2. Then they will be same transaction. Okay, so two different transactions can never have same timestamp. So the answer will be here that either they can be same transaction or, okay, so in the options if you have this is also correct. There is no problem. See, in the options if this is there, this is also fine, or they can be same. Okay, either they are the same transaction or T is less than equal to G. So very simple, this question number 16. Did you understand this question number 16? Now let's see the question number 17. Tell me the answer here. There is a schedule that is allowed by timestamp. There is a schedule, and we are saying that assume that transaction T is writing item X. After some point of time, G is writing item X. Right. Then what you can say? Again, the similar question. We are saying that there is a T, there is a G. We don't know their timestamp, but this is saying that this is writing item X. After some point of time, this is writing item X. Then what you can say about their timestamp order? What you can say about timestamp of T, G? What can we say about timestamp of T, G? Again, the answer will be what? Answer will be T timestamp of, I can say the timestamp of T will be less than equal to timestamp of G. Okay, this timestamp of T will be less than equal to timestamp of G. Sorry, here basically I am saying timestamp. Okay, let's move on. So this is the question. So again, you can notice that timestamp of T will be less than equal to timestamp of G. Next, what is the next? Let's see this question. Question number 18. Again, there is a schedule that is generated allowed by timestamp. Transaction T is reading item X. After some point of time, transaction G is reading item X. What you can say? So transaction T is reading item X. Then after some point of time, transaction G is reading item X. What can you say about their timestamp? What can we say about their timestamp? Nothing can be said. Yes or no? We can say nothing. Nothing can be said. Nothing can be said, right? Because there is a transaction T, there is a transaction G. You have two transactions. This is reading item X. After some point of time, this is reading item X. We cannot say anything. All the possibilities are fine. All the possibilities are fine. We cannot say anything about timestamp of, I can say timestamp of T, timestamp of G are not comparable, or information is not sufficient. Okay, because information not sufficient, it simply means that information not sufficient. We don't have sufficient information. So this information is not sufficient. Okay, for this question, the information is not sufficient. We cannot say anything about their timestamp. Nothing can be said. Because remember, simple thing I am saying that, let me assume a simple thing I am saying that these things are fine in TSP. In timestamp protocol, these things are fine. For example, let's assume there is T1, there is T2, and there is T3. And let's assume this is their timestamp ordering. Let's assume this is the order of timestamps. So I am saying that this is the order of timestamp. This is the order of timestamps. Now, remember, these things are perfectly fine. Which things? Like these things are perfectly fine. For example, this is reading X, then this is reading X. There is no problem. There is no, okay, it is perfectly fine. Because this is not a conflict pair. This is not a conflict pair. So these things are perfectly fine. For example, this is writing item X and this is writing item Y. This is also perfectly fine. Remember, this is also perfectly fine because these are not conflict pair. So this is also fine. So this is what I'm saying, that as long as you don't have conflict pair, these things are fine. Like this is writing item Y, this is writing item Z, this is reading item X. Okay. So all these things, this is reading item X. All these things are fine. This is perfectly fine. There is no problem. Okay. So as long as you don't have conflict, it is fine. Like this is not fine. For example, this is writing item X and after some point of time, this is reading item X. So this is not fine. This is not allowed. Okay. Because this is a conflict. This is a conflict pair. So this is not allowed. Let's move on to the next question. This is the question you are waiting for. Some of you are waiting for this question. Do you, right? So let me tell you, this is a court question. The question is from court. What the question is saying? The question is saying that why? What is the reason? What is the reason? Reason. You give me the reason. So the question is asking for why. Why an aborted transaction restarts with a new timestamp instead of old timestamp? What is the reason? Can you tell me? Like in the timestamp protocol, when a transaction is rollbacked under timestamp ordering, it is assigned a new timestamp. Why we can't give it the old timestamp? What is the reason? What is the reason we give it a new timestamp? Why we cannot give it old timestamp? This is a question from the court. This is a standard question. Yes, very good, Yuvraj. Very good. This is the question 19. Because it will again roll back. The answer is very simple. The answer is very simple. Why? The answer is very simple. Because it will again roll back. Because it will again roll back. It will again roll back. It will again abort if this happens. See what I am saying. Let me tell you what I am saying. Now consider this scenario. Just consider this scenario. Let's assume this transaction, there is a transaction T. I am giving you a transaction T. Okay, or maybe transaction T1. Now in this transaction T1, let's assume it wants to read item X. Okay. It wants to read item X, it wants to read item Y, and so on. So this is what this transaction wants to do. Now consider this scenario. Just consider this scenario. Let me assume that timestamp of T1 is less than timestamp of T2. Okay. Let me assume this. Assume that timestamp of T1 is less than timestamp of T2. Let's assume. Now assume this happens. Okay, let's assume, again I am saying that T2, let me give you the transaction T2 also, let me give you transaction T2. This T2, what it does, it writes item Y. What it does, it writes item Y. Okay. Now consider this scenario that you already know that this is the timeline. Yes or no? This is the timestamp order. What is the timestamp order? This is the timestamp order, that this T1 and then this T2. This is the timestamp order, correct? Now consider this scenario. What happens? You know that timestamp of T1 is less than timestamp of T2. Okay. This T2 is writing item Y and this T1 is reading X, reading Y. Now you can see that if this happens, like let's assume this is T1, this is T2. Let me assume that it reads item X, then it writes item Y, then it reads item Y. Now tell me what will happen. Remember this. Tell me what will happen. Like this is reading item X, this is writing item Y, then it is reading item Y. This scenario happens. Now tell me what will happen now. Tell me what will happen now. This is not allowed, correct? Yes or no? This is not allowed. So if this is not allowed, then what will happen? Then here T1 roll back. So at this point of time, T1 will roll back, correct? They definitely T1 will roll back. Okay. Now assume you start with, again if you start, let's assume again you start this T1. Now this T1 will roll back. This T1 has roll backed. Okay, this T1 has roll backed. So this T1 is gone. T1 is gone. T1 is gone. T1 is gone. Okay, this T1 is already gone. Now this restarted T1. This is the restarted T1. If the restarted T1 has less time, if you restart with the original timestamp, if T1 restarts, tell me now, can you see the problem? If T1 restarts with old timestamp, can you see the problem? Can you see the problem? If transaction T1 restarts with old timestamp, this is restarted T1. So if you start with the old timestamp, then again it is older. Right? Yes or no? Then again what will happen? This is the time that is going on. The time is going on like this. Again what will happen? It will restart. Okay, again what will happen? The same thing will happen, that it will read X, it will read Y. Again this will roll back. Again this will roll back. Again T1 rollbacks. Again T1 rollbacks. So now is this crystal clear that we cannot restart any transaction with the old timestamp? Is this crystal clear? Tell me, please tell me. Is this crystal clear? Then in this timestamp protocol, aborted transaction must restart with new timestamp. Yes or no? It must start with the new timestamp. Else it will again roll back. Else it again rollbacks. Is this crystal clear? Tell me that it must start with new timestamp. Let me know. Please tell me. Is this question clear? Because this is a course question. This is a standard question. Array, this is important. This is course. These questions from the standard resources, they come in the GATE exam as it is. Standard questions from the standard resources come in the GATE exam as it is. So this is a course question. So is this understood that we must start with new timestamp. We must start with new timestamp. We cannot start with the old timestamp, because if you start with old timestamp, then it will again roll back. It is going to again roll back. Okay, so you must start with new timestamp. Now let's move on to the next question, number 20. Question number 20, tell me the answer. True or false? Simple question, true or false? the timestamp scheduler, there is a scheduler, timestamp scheduler, assumes that the timestamp order of transactions, okay, it is basically this timestamp scheduler, there is a timestamp scheduler. This assumes that the timestamp order of transactions, the timestamp order of transactions is also the serial order in which they must appear to execute. Is also the serial order in which they must appear to execute. They must appear to execute. So this statement is true. This is the basic idea of TSP. Yes or no? This is the basic fundamental idea of the TSP. Do you agree? Correct or not? This is the fundamental idea that in TSP, the equivalent serial schedule is basically the same, in the same order as the timestamp order of the transactions. So this is true. This statement is true because in the TSP, what happens? In the timestamp protocol, what happens? In this timestamp protocol, for any schedule S, what will happen? The equivalent serial schedule, this equivalent serial schedule has this equal serial schedule is in the order, I can say, is in the order of timestamps of transaction. Timestamps of transactions. So this is the definition actually. Let me tell you, this statement is just a definition, right? In the order of a timestamp of transactions. So this statement is true and this is just a definition of a timestamp protocol. Question number 21. Tell me the answer. Tell me the answer for question number 21. In any schedule, the transaction that executes the first data access has the least timestamp. In any schedule, the transaction that executes the first data access has the least timestamp. Is this true? What this question wants to say, let me tell you. Is this true that if this happens, let's assume there is T1, there is T2, there is T3. If this happens that this is doing the first data access, this is doing the first data access. Okay, then let's assume this is doing the data access. Then let's assume this is doing the data access. Like this is what I'm saying. Then let's assume this is doing the data access. So now you tell me, can I say this will have the least timestamp? Can I say T2 has the least timestamp? Can I say that T2 has the least timestamp? Can I say? Does it imply? Tell me, does it imply this complete situation? Does it imply T2 has least timestamp? Tell me, has least timestamp? The answer is very clearly no. Let me tell you. The answer is no. This statement is false. Why this statement is false? Remember, it does not mean that timestamp means the transaction arrival. Remember this point. So remember, what is timestamp of transaction? Timestamp is given when transaction arrives. Okay, to any transaction. So whatever transaction you take, to any transaction T, when timestamp is given, tell me. Timestamp, this timestamp, when this is given, this timestamp is assigned when T arrives or created or submitted to the system. Okay, so when it arrives in the system. So remember, when it arrives in the system, then timestamp is given to it. So for example, here it can happen. It is possibility that maybe this is the least timestamp. There is no problem. For example, let's assume there is a timestamp T1. Okay, so timestamp T2. It is perfectly fine. Remember, so this is actually the least timestamp. You can see this is the least timestamp. This is the least timestamp. And there is no problem, like this is perfectly fine. For example, maybe this T2 is doing the read operation. Then this T1 is doing the write operation. Something like this. So all these things are fine. Are you getting my point? So it is actually older. It is actually older. It does not mean that it will do the access first. It will do the first access. So is this clear? Question number 21. Are you comfortable that in any schedule, the transaction that will execute the first data access has the least timestamp? The answer is false. This statement is false. Let me tell you, this is a standard question from the Ullman book. This is a Ullman question. Okay. So question number 21 is done. Now let's see. So this is the note. The timestamp ordering protocol. So very simple. You already know this. You already know that timestamp ordering protocol ensures that any conflict in read and write operations are executed in the timestamp order. Okay. This is the idea, that in the timestamp ordering protocol, any conflicting read operation, write operation will execute in the timestamp order. This we already know. Now let's see this question. Some beautiful questions we are going to solve now. So tell me right now, till question number 22, are you comfortable? Question number 1 to question number 22. So far, are you comfortable? Did you understand everything? Tell me, did you understand? Did you clearly understand everything? Can you visualize all the concepts that you are learning? Can you visualize? Like in your mind, can you visualize? Did you clearly understand? Okay, so now, this is fine. Ekta, read this statement. The timestamp ordering protocol ensures that any conflict will happen in the timestamp order. This is the statement. We are saying that every conflict order will happen in the same order as the timestamp order. So this statement is fine. Question number 22. Do you have any doubt in the question number 22? Where is question number 20? Okay, so I think there is no question number 22, right? Okay, so I can say 21. We have done only question 21. This was the question 21. Okay. So anyway, so everything is clear now. Yuvraj, Ekta, Sumant, please tell me. All the doubts so far, all the doubts are clear. Now let's see the next question. So tell me the answer for this one. This is another nice question. Tell me. So which action will be taken by the timestamp scheduler? What action will it take? Will it allow? Will it roll back? What it will do? Which action will be taken by the timestamp scheduler? Read this question. That transaction T tries to read data item X, but the write time of X indicates this. Read this question and tell me the answer. Correct answer I want. This transaction T tries to read item X, but the write time of X, see this, write time of X indicates that transaction T, timestamp of transaction T is less than write timestamp of X. So in these questions, what is the best way? Can you tell me what is the best way to solve this question? To solve this question, what is the best way? The best way is create a chart. Okay. The best way is to create a chart. What you do? What the question is saying? The question is saying that there is a transaction T. Okay, there is a transaction T. Wants to read X. It wants to read X. But what the question is saying? The question is saying that timestamp of T is less than write timestamp of X. Okay. Timestamp of T is less than write timestamp of X. So what is the diagram actually? See what it means. This is the, what is the highest? This means the highest transaction timestamp. The highest timestamp. What this means? This means the highest timestamp, right? Of transaction. Okay. So this WTS of X, what this means? This means that this is the highest timestamp of transaction successfully writing X. Correct? Now the question is saying that this timestamp of T is less than this. What it means? It means this is the T and there is some bigger transaction. There is some bigger transaction who has already written X. Do you agree? Do you agree that there is some bigger transaction who has already written X? There is some bigger transaction who has already written X. Now this T1 wants to read X. This conflict is not allowed. This conflict is not allowed. This is interesting question, right? Finally, I can say a good question for the gate level, for the gate exam. So in the gate exam, like this type of question comes, they give you this equation. They give you this equation and then they ask you what it will do, what action will be taken. Please tell me, did you understand this? The question is very simple. We are saying that, first of all, write timestamp of X is given to you. The question is saying write timestamp of X is greater than timestamp of T. Write timestamp of X. Okay. It means, so you just read the question and solve this. Try this. Give me a second. Hello. Hi everyone. So, okay, is this question clear to everyone? Then what is happening? That because timestamp, the right timestamp of X, what it means? That who is writing X? Who is writing X? So so which is the highest transaction? Which is the youngest transaction to write X? So basically there is a transaction, younger transaction who has already written X. Then this transaction is writing X, reading. Then this transaction T is reading X. So this is not allowed. In this situation, what will happen? This is unsuccessful, right? Correct? This is unsuccessful. This is unsuccessful read. So here what will happen? Here transaction T rollbacks. And restarts with what? So what action will be taken? Action will be taken T rollbacks. And restarts with new timestamp. Okay. And it will restart with the new timestamp. Okay, so it will restart with new timestamp. So very simple. So you can see actually this diagram, you can notice this is the diagram from the Ullman book. This diagram, you can notice what is happening. See, this transaction T wants to read, but the right timestamp of X is already greater. Remember, this T wants to read. This T wants to read X. So what is happening? It's happening something like this. Let's assume this is the time that is going on. In this direction, time is going on. What is happening? That this T started first. Remember? So maybe this T actually started first. This is the timestamp of T. So this T started first. After this, some transaction U started. Some transaction U. What the question is saying? Maybe the U is writing. Maybe this is equal to U. Maybe there is a transaction U. Maybe there is a transaction U which is writing X. Maybe there is a transaction T U which is writing X. So there is a transaction U which is writing X. So here write X is done by U. Okay, after this, this transaction T wants to read X. So definitely this is not allowed. In this order, the conflict cannot happen. So in this order, the conflict cannot happen. So this is not allowed. In this order, the conflict cannot happen. Anyway, you understood. So let's move on now. Let's see this question. Question number 24. Can you tell me the answer for this? Question number 24. Give me the answer for this. Which action will be taken? So tell me, what is the answer for this one? Which action will be taken? Transaction T tries to write data item element X. Okay, it wants to write item X. However, the read item of X, basically this equation is given to you. Basically, this equation is given to you. Okay, the read item of x indicates that some other transaction should have read the value written by t, but it read some other value. Okay, so basically this equation, focus on this equation. Just focus on this equation. What the question is saying, there is a transaction t. The question is saying like this, there is a transaction t. It wants to write item x. Okay, it wants to write item x, remember? And the question, this equation is saying, this equation is given. What the equation? The equation is this, that timestamp of t is less than read timestamp of x. Okay, this is given. Now you just create the chart. What you do? You just create the chart. First of all, what this means? First of all, what this means? This means the which is the youngest transaction. Which is the, I can say, this is the highest. This is the highest timestamp. Okay, so remember, this is the highest timestamp of transaction reading x, successfully reading x. Okay, so this is your RTS, means read timestamp of x. So who is the youngest person to read x? Okay, so this is the, yeah, I can say this is the youngest transaction to read x. Who is the youngest person? Who is the youngest person to read x? Who is the youngest person to read x? So basically there is a, this is greater than, this is basically what it means t wants to write x. So this t, this transaction t wants to write x. It wants to write x. This is what it want to do. But already there is some younger transaction. There is some younger transaction has already read the item x. So this is again a conflict. Yes or no? This is again a conflict, and this is again not allowed. Again, this is not allowed. Again, what will happen here? This will be unsuccessful. Again, here what will happen? Here I can say transaction t rollbacks. Is this clear? Please tell me. Yuvraj, Ekta, is this clear? So here again the transaction t rollbacks. So what action will be taken? The action will be t rollbacks. Here also t rollbacks. Very simple. Now let's move on. So these are simple questions. So you can just easily see. Tell me the answer for this question quickly. Quickly tell me the answer for this one. Is this schedule allowed by 2PL? On your screen, a schedule is given to you. Is this schedule allowed by 2PL? Is this generated by, by timestamp protocol? Is this allowed by timestamp protocol? These are the timestamps. These are the timestamps that are given to you. These are the timestamps. What is the first thing you will do? Tell me. In the GATE exam, if this question comes, actually this is a Ullmann question. Let me tell you again. This is a Ullmann question. If this question comes, this is a standard question. If this question comes in the exam as it is, then what is the first thing you will do? What is the first thing you will do? First, you will convert this transaction into, because remember here, see, please understand that this is the oldest. This is the oldest. This is the youngest. So what is the first thing you will do in the GATE exam? If this question comes, what will you do the first thing? First, you will convert, yes, right, because you are not comfortable with this order. You are not comfortable with this, but you are very comfortable if I write like this T2 is 150. Okay. Then this T3 is 175. And then this T1 is 200. You are very comfortable. Can I say you are very comfortable with this order? You are very comfortable with this order, right? Yes or no? Correct. Now everything, remember the time is going like this. The time is going like this. What it means, everything else will be like this. So this T1 is reading item A, this T1 is reading item B. So this T1 will read item B. Okay, it will read item B. Then this T2 reading item A, then this T3 reading item C, then this T2 reading item A, then this T3 reading item C. Next, then T1 is writing B, writing A. T1 is writing B, writing A, then T2 is writing C, then T2 is writing C, and then T3 is writing A, then T3 is writing A. Okay, that's it. So now you tell me, is this schedule allowed or not? On your screen, this is the first thing to do. Now we are comfortable, I can say. Now we are comfortable. Now we are comfortable, right? Yes or no? With this order, we are comfortable. We are more comfortable with this order. So now you tell me, so you can easily check that. Just find the conflict. Just find the conflict pairs. So where are the conflict pairs? Just find the conflict pairs. So you can see that this is a conflict. This conflict is perfectly fine. Yes or no? This conflict, look at this. This is a conflict and this is a perfectly fine. Do you agree? Do you agree that this conflict order is fine? This conflict order is fine. So we don't have any problem with this conflict order. This conflict order is perfectly fine. What about this order? What about this order? What about this order? This conflict order is not allowed. Yes or no? This is not allowed. If this is not allowed, then who will roll back? So this is unsuccessful. So what will happen? So this will become unsuccessful. So here you can notice this. At this point of time, I can say T3 rollbacks. So this will be unsuccessful. So remember that this operation is unsuccessful. Unsuccessful. So this will be rollback. So this will be gone. Okay, so this is going to be gone. Rollback. Okay, so this is gone. So very simple that this point will be gone. This transaction will be gone. And after that, there is no problem. So here, is this allowed? The answer is no. Is this schedule allowed? The answer will be no. The T1, they're basically T1 rollbacks. Sorry, which rollbacks? T3 rollbacks. So I can say T3 rollbacks. T3 rollbacks. Is this understood? Is this understood that that is T2. Sorry. That is T2. So T2 rollbacks. Sorry, that is T2. So that T2 will roll back. That is T2. So here the T2 will roll back. Okay. So T2 rollbacks. So this is not allowed and T2 will roll back. Very simple. Okay. And once T2 rollbacks, now there is no problem. So once T2 will roll back, see, now the T2 will be gone. Now the T2 has rollbacked. The T2 has rollbacked. Will there be any other rollback? T2 has gone. T2 has gone. Remember, T2 has gone. Now, is there any other rollback? Is there any other rollback? T2 rollbacked. T2 rollbacked. T2 rollbacked. Now, is there any other problem? Do we have any other conflict? There is no other conflict, right? Yes or no? So this is perfectly fine. So this is perfectly fine. Fine by TSP. So there is no other rollback. The only rollback will happen for T2. So for this question, remember this is a Ullmann question. For this question, T2 will roll back. Ultimately, here this T2 is going to roll back. This T2 rollbacks. Very simple question. So now you can solve actually all the variations, all the questions you can easily solve. So you can notice. So here you can notice that T2 will roll back. Let's move on. Let's see this question. This is another question from the from which university? Some, I think Stanford or Berkeley something. So tell me the answer for this one. How many transactions will roll back? How many transactions are aborted by the timestamp scheduler? How many transactions will be aborted by the timestamp scheduler? This is your question number 26. Question number 26. How many are going to be aborted by the timestamp scheduler? And the question has already given you the information that the timestamps are 1, 2, 3, 4, 5. So basically this is already in the timestamp order. This is already in the timestamp order. These are already given to you. Now let's find out which are the just find out the conflict pairs. All you have to find is conflict pairs. This is perfectly fine. Yes or no? There is no problem. This is perfectly fine. We don't have any problem here. There is no problem. So I can say this is fine. I can say this is, the red ones are fine. Okay, so this is what I'm saying. These are fine. Fine arrows. And when I write like this, then these are not allowed arrows. This color means not allowed arrows. Okay, so not allowed arrows. What are the not allowed arrows? See, you can see this is not allowed. Correct? This is definitely not allowed. Okay, but what is the first thing that will roll back? See, what is the first thing that will roll back? So this is allowed. This is all allowed. Always go step by step. Always go step by step. Okay, remember, you must always go step by step. So you can see that this will, this is also fine. Now, what else? So this is WX. So this is not fine, correct? This is the first thing that will roll back. Do you agree? This is the first thing that will roll back. So because this is not fine. Okay, so this is not allowed arrow. So remember here, who will roll back? So at this point of time, this is unsuccessful. Please understand that this is already unsuccessful. This is already unsuccessful. And at this point of time, already who is gone? T2 gone. T2 roll back. Okay, at this point of time, already T2 roll back. So T2 is going to roll back. Clear? So will T1 roll back? Tell me. Simple question I am asking. Will T1 roll back? Array, T2 is roll backing. This is a beautiful question. Let me tell you. This is a beautiful question because the reason is very simple. See, when you are here, already T2 is gone. Correct? At this point of time, already T2 is gone. Do you agree that at this point of time, already T2 is gone? At this point of time, T2 is already rolled back. So T2 is gone at this point of time. This is what I'm saying, that T2 is already gone. Okay, so this T2 will be already gone. Just remove it. Just remove it. T2 is already gone. At this point of time, T2 is already gone. Okay, so now you can notice T1 will not roll back. There is no problem here. There is no problem here. We don't have any problem here. So T1 will not roll back. Okay, is this clear? So remember, T1 will not roll back. Isn't it a beautiful question? Tell me. Are you finding this question beautiful or not? See, the mistake, let me tell you. What is the mistake? This is a big mistake. What is the big mistake? Now you can notice that the big mistake, let me tell you. So now you can notice that this will not roll back. So there is no problem. This will not roll back. This will not abort. So is this clear? This is a big mistake. This is a big mistake. What is the big mistake? Can you tell me what is the big mistake? What is the big mistake? Big mistake is if you do like this. For example, okay, if you randomly go and you abort this T1 and you abort T1. If you randomly go and you abort T1, this is a big mistake. Do you agree this is a big mistake? Tell me. Will you keep this mistake in mind? Will you keep this mistake in mind that T1 will not abort? Remember, T1 will never abort because there is no issue. There is no issue. No issue. There is no issue. There is no issue. So this is a big mistake if you go randomly. Because in this question, something beautiful is happening. What is that? Something beautiful because it is already aborting. See, this something beautiful is happening because this is not a problem because it is already gone. Is this point clear? Let me know. Because this is already aborted. This T2 is already aborted. So this T1 will not abort. This T1 will not abort because T2 already aborted. Remember, the time is going like this. So things will happen one by one. Okay, all these things are happening one by one. One by one, all these things are happening one by one. So this is this is the reason I have taken this question. This is a standard question, and I hope this type of question comes in the GATE exam. You will find this type of question in which test series? In the Go classes test series. Okay, because all the nice questions, all the questions where basically which can improve your knowledge, all the questions which can make sure that your misconceptions are gone, all the questions to remove your misconceptions, to improve your knowledge, those are already in the Go classes test series. So in the Go classes test series you will find similar questions to this. Okay, very similar questions are already available on the Go classes test series. So you can attempt that test series for more beautiful and for more amazing questions. So you can see here that this T1 will not roll back. Okay, what else? Tell me what else? Now is there any problem? Who will roll back? So this T1, now let's move on. Now let's see this. Okay, what about this? So after this T1, who will roll back? Now you can notice this will roll back. Yes or no? So at this point of time, who will roll back? So at this point of time, T3 rollbacks. At this point of time, T3 abort. So this T3 will abort. Now this T3 is also aborted, and that's it. Then there is no other problem. So finally the answer will be that two transactions are aborting. Okay, this T1, T2. So these are the aborted. These are aborted. So the answer will be what? The answer will be two transactions aborted. Tell me, did you understand this question? Let me know, did you understand this question? Please tell me. Did you understand this question? Please tell me. Very simple, but this is a beautiful question, and this is a GATE, I can say, GATE exam will ask you this type of question, because the GATE examiner knows that you will make this mistake. You will go randomly. You will not go according to the time. Always go according to the time. This is how the things are happening. Okay, already this will be aborted, so there is no problem here. So this T1 will not abort. So this is a simple question, and the answer will be 2. 2 rollbacks will happen. 2 transactions will roll back. 2 transactions will abort. So this is your question number 26. Let's move on. So far all the question number 26, are they clear? So far are you comfortable till question number 26? Question number 1 to question number 26. Are you comfortable? Did you understand crystal clear? Like this crystal clear understanding did you have? Crystal clear understanding do you have now? Tell me. Okay, so let's move on now. Now let's see this question number 27. Tell me the answer. Timestamp protocol ensures conflict serializability. Timestamp protocol, it will ensure conflict serializability. The answer is yes or no. And if it is yes, then why? Timestamp protocol will ensure conflict serializability. It will ensure conflict serializability. The answer is yes or no. If it is yes, then why? Okay, so tell me the answer. The answer will be yes. The answer will be yes. It will ensure conflict serializability. But why? What is the reason? Can you tell me the reason? It will ensure conflict serializability. There is no doubt. There is no doubt it will ensure conflict serializability. But what is the reason? What is the reason? Why? Because the reason is very simple. Because whatever conflict will happen in the order of transactions. Yes or no? See, this TSP guarantees, it ensures that it ensures conflict serializability. Why? See, it will ensure conflict serializability. What is the reason? Because all the conflict operations will happen in the order of transaction timestamp. Yes or no? it will ensure conflict serializability because all conflict operations will happen in which order? Tell me in which order they will happen. All conflict operations happen in happen all conflict operations happen in the order of timestamps, in the order of transaction timestamps. Correct? In the order of transaction timestamps. So all the operations that will happen, all the conflict operations will happen in the order of transaction timestamps. What I want to say is that all the conflicting operations, they will happen in this order. Do you agree in this order? That in this order they will happen, that transaction with less timestamp to transaction with more timestamp. Do you agree? Do you agree that in this order things will happen? Tell me, do you agree that in this order the conflict will happen? Every conflict will happen. All the conflict operations will happen in this order. Okay, every conflict operation is going to happen in this order. All the conflict operations, they will happen in this order. From timestamp with less transaction with less timestamp to transaction with more timestamp. In this order, the conflict operations will happen. Okay, so you can so in the precedence graph you will never have cycle. So in precedence graph, can you ever have cycle? So in precedence graph, can you ever have cycle? Simple question. So in the precedence graph, we can never have cycle. Correct? We can never have cycle. Is this clear? In the precedence graph, we can never have cycle because your precedence graph will go like this. There is a transaction T1 with timestamp is equal to, let's assume 100. So from here, there will be arrow like this T2 and the timestamp is, let's assume 200. You can never have this arrow. This arrow is never possible. Never possible. This is never possible. Is this clear? Tell me. Did you understand the proof? The proof is important. Did you understand the proof that the precedence graph can never have cycle? This precedence graph that you will create, it will never have cycle. Because the conflict will happen in this order. If you have transaction T1, transaction T2, transaction T3, in this order if you have, then conflict will happen in this order, like write X, then the conflict will happen in this order. Only in this order conflict can happen. So you can never have this, like from T1 to T2, from T2 to T3, you can never have this. This you can never have. Okay, right? This you can never have. You can never have this. We can never have this. So in the precedence graph, we can never have cycle. Understood? The proof, did you understand? The why did you understand? The proof. Prove it. So did you understand it? So timestamp protocol will ensure conflict serializability. It will always ensure conflict serializability. That is yes. Okay, but what is the proof? What is the proof? The proof is that you can never have cycle in the precedence graph. In the precedence graph, the precedence graph that you create, in that precedence graph, you can never have cycle because you can never have this type of situation. This cyclic situation you can never have. So that is the reason I can say TSP, timestamp protocol, ensures conflict serializability. What about this question? What is the answer for this one? Timestamp protocol suffers from deadlock. Will it suffer from deadlock? Will it suffer from deadlock? The answer is no. But why? Can you prove it? Can you prove it? Why? Can you prove it? Can you prove why? It will never suffer from deadlock. Can you prove why? Because we never wait. A transaction never waits. Yes or no? Because a transaction never waits. Did you notice that? Because a transaction never waits. Transaction never waits. Yes or no? Never waits. A transaction never waits. It will immediately abort. Do you agree? It will immediately abort. If transaction is not granted a request, it will abort. If transaction is not granted, I can say, if transaction is not able to do an operation, not able to do an operation, then it abort. Then it aborts. Yes or no? Then it immediately aborts. It will never wait. Did you notice? It will never wait. It is never waiting. A transaction will never wait. No transaction will ever wait. Okay, like some problem happens, it will roll back. Some problem happens, it roll back. So for example, if some problem happens, like if this type of problem happens, then immediately what will happen? At immediately here T1 rollbacks. So T1 will never wait. So here again T1 rollbacks. So you can easily see that immediately the transaction will roll back. You will never wait. No transaction ever waits. It will just roll back. So very simple that it does not suffer from the deadlock because we never wait. Is this basically the explanation? The reason is this reason clear? The reason is clear that a transaction will never wait. If you are not able to perform some operation, then you will abort. Then you will immediately roll back. So you will never wait. So because you are never waiting, so there is no possibility of deadlock. What about starvation? What about starvation? Timestamp protocol suffers from starvation. It suffers from starvation. Is it true? Does it suffer from starvation? Timestamp protocol, does it suffer from starvation? This is your question number 29. The answer is yes, it suffers from starvation because maybe you can again roll back. You come back, you restart, and again you can roll back. You restart, again you can roll back. You restart, again you can roll back. So starvation is possible. Yes or no? Starvation is possible. So the answer will be yes. Starvation is possible because maybe, see, consider this scenario. T1 is less than T2. Now let's assume T1 rollbacks. Let me assume T1 rollbacks. Okay, so for example, this is write and this is read. Now let me assume that T1 rollbacks. So here what will happen at this point of time? T1 rollbacks. Okay, T1 rollbacks. Now let's assume T1 comes to the system again. Again T1 comes to the system. Again T1 comes to the system. So again let's assume this T1 restarts. This T1 restarts. But again the same situation happens. Let's assume there is a T3 which again has write operation and then this read operation. Then again what will happen? Then again this T1 rollbacks. So starvation can happen because maybe you can again continue the rollback. Okay, maybe the future transactions, maybe they can again make you roll back. Okay, actually, for example, maybe this T1 is a long transaction. 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 Maybe this is a long transaction. So many things it will do and again it will roll back. Is this clear? Ekta, Yuvraj, Sumant, is this clear that you have a long transaction? When it comes back, again you roll back. Okay, very simple scenario I am giving. So let's assume there is a long, this T1 is a long transaction. This T1, this is a very long transaction. Let me assume this is a long transaction. Now you can notice it will again come to the system. Then it can again roll back because of T3. Okay. Again it will come to the system. Again it will roll back because of something new. So like this, this long transaction can roll back many times. Yes or no? This long transaction, it can roll back many times. So the starvation is possible. So there is a possibility of starvation. Remember, we have, so you can notice there is a possibility of starvation of long transaction. If you have a long transaction, then there is a possibility of starvation because the short transactions, they will repeatedly cause you starvation. Cause you abort. Okay. So very simple. This is the simple scenario. So this T1 is a long transaction, very long transaction, and it will again roll back because of T2, again because of T3 and so on. So like this. So the so starvation is definitely possible. What about this question? Timestamp protocol ensures recoverability. Is this true? timestamp protocol, does it ensure recoverability? Does it ensure recoverability? The answer is no, and you can easily create a counterexample. You can very easily create a counterexample. Like consider this example. Consider T1 and this timestamp is less than T2. Let's assume, okay, T1 timestamp is less than T2 timestamp. Maybe this is the write operation, this is the read operation, this is perfectly fine, and this is the commit. Okay, and this is the commit. So this is, you can clearly see this is perfectly fine. Yes or no? This is allowed by TSP. Correct or not? Are yes or no? This is allowed by TSP. Yes or no? This is perfectly fine. This is fine. This is perfectly fine. This is allowed by TSP. You can commit here. So this okay, and this T1 can abort here. So you can note this is not recoverable. This is a not recoverable. So recoverability is not ensured. Okay, recoverability will not be ensured. You can easily see that this is not recoverable. This schedule is not recoverable. Okay, let's move on. Timestamp protocol avoids cascading rollback. Is it true? Timestamp protocol avoids cascading rollback. Tell me. You have your timestamp protocol, does it avoid cascading rollback? Does it avoid cascading rollback? Again, the answer is no. It does not avoid cascading rollback. Okay, it will. You can easily again give a counterexample. For example, let's assume T1. Let's assume there is a T2. Let's assume there is a T3. Let's assume there is a T4. Let me assume this is writing item X. This is writing item X. It is reading X. It is reading X. It is reading X. Okay. Now notice what is happening. See what is happening. At this point of time, if this T1 abort, at this point of time, let's assume this T1 aborts, then automatically what will happen? See, this is reading. This is reading also. This is also reading. This is also reading. So everyone is reading from T1. And at this point of time, if T aborts, then who will abort? Then automatically T2 has to abort, T3 has to abort, T1, T4 has to abort. Okay. So all of them have to abort. So this is your cascading rollback. Yes or no? This situation is called cascading rollback. So cascading rollbacks are happening. Yes or no? Cascading rollbacks are happening. So does it avoid cascading rollback? The answer is no. Does it avoid cascading rollback? The answer is no. Question number 31, the answer is no. Okay, so you can easily see at this point of time, if T1 fails, at this point of time, if T1 fails for any reason, if T1 fails or aborts, then cascading rollback will happen. So, okay, very simple. So very easily, you can see this is the summary, the complete summary I am telling you. This is the complete summary. Please see this. The timestamp ordering protocol guarantees serializability, conflict serializability, because all the arcs in the precedence graph will be like this. Transaction with smaller timestamp to transaction with larger timestamp. Okay. So there is no cycle in the precedence graph. So conflict serializability is definitely. So I can say actually the conflict serializability is guaranteed. The conflict serializability is guaranteed. Recoverability is not guaranteed. Cascade free is not guaranteed. Okay, these things are not guaranteed. These things are not guaranteed. But freedom from deadlock is guaranteed because no one ever waits. No transaction ever waits. There is no transaction who will ever wait. There is no waiting. Okay, so very simple. Is this clear? In this question, Ekta, see, if this T1 fails because of any reason, then T1 must roll back. Yes or no? In question, we saw not all rollback. See, consider this scenario. In this scenario, T2 is reading from T1, T3 is reading from T1, T4 is reading from T1. Every transaction is reading from T1. So if T1 fails, then T2 should roll back, T3 and T4, they all should roll back. So this is called cascading rollback. Okay, so cascading rollback is possible in the timestamp protocol. So I can say in timestamp protocol, cascading rollback possible. Okay, cascading rollback Possible. It is possible. Okay, let's move on now. Now let's see this question. So which question number? Question number 32. Standard question I have taken. Question number 32. Tell me the answer. This is a Washington University question. The source of this question, let me tell you, this is the source is Washington University. Washington University question. So tell me the answer. Question number 32. एक था, you are writing something and if I cheat from you, so I'm reading from you. Now, if you roll back, then I also have to roll back. Right? Yes or no? So that we have already seen in the recoverability. Did you watch the recoverability lecture? Recoverability, strict schedule, recoverable schedule, cascade-less schedule, all these concepts we have already seen. You can watch that video in our DBMS complete course. GoClasses DBMS complete course. You can watch the recoverability lecture. There we have seen all the scenario, all the possibilities, all the basically all the gate questions, everything we have seen. So please watch that. So tell me the answer for this question. What is the answer? How many of the statements are true? How many of the following statements are true? Which of them is true? Deadlock is not possible with timestamp protocol. Deadlock is never possible with timestamp protocol. This is correct. Because no one waits. Because no one waits. Yes or no? Because we never wait. Because no transaction waits. Because no transaction ever waits. Okay, so this is correct. This statement is definitely correct. This statement is true. A transaction that arrives later to the system always has smaller timestamp. A transaction that arrives later to the system always has smaller timestamp. This is wrong. This is wrong. It will actually have larger timestamp. Yes or no? It will actually have larger timestamp. So for example, this smaller must be larger. It must be larger timestamp. So if you arrive late, you will have larger timestamp. Okay. Now let's see the next. Next, you can notice the precedence graph for the timestamp algorithm. So you can see that the precedence graph for the timestamp algorithm has edges from smaller timestamp to larger ones. So yes, this is correct. The third one is definitely correct. Okay. The third one is definitely correct. In the precedence graph, what will happen in the precedence graph? In the precedence graph, the transaction with less timestamp, okay, these edges will be from this transaction to this transaction. Okay, so this is actually correct. This is statement number 3 is correct. A write is only performed. Now let's see the option number 4. Look at the option number 4. A write is only performed if. This is only if. This is only if. A write is performed only if transaction has timestamp greater than read timestamp of that data item. So this is also correct. Yes or no? This is also correct. This statement is also correct because this is only if statement. See, look at the statement number 4. What the statement number 4 is saying. This is saying that a write is performed. Write, for example, write x by t happens when it happens only if. This is only if. Only if means this direction. Only if is the forward direction. Okay, only if transaction this t timestamp of t is greater than equal to read timestamp for data item. Timestamp for data item. So tell me, is this correct? Is this correct? Simple question I'm asking. First of all, what is the direction of only if? You tell me a simple question I'm asking. You tell me true or false. Tell me, what is P only if Q? What is P only if Q? Can you tell me? What is P only if Q? What is that? P only if Q is P implies Q. Right? Yes or no? P only if Q, that is P implies Q. So here actually you can see that this means this only if you can remove, and you can put this arrow. You can put this arrow. So if this right operation is happening, if this T is doing the right operation, if this is happening, then what should happen? If this should be successful, then what should happen? Then definitely this time stamp of T must be greater than the read time stamp of X. So this is definitely true. So this statement is actually true. Yes or no? This statement is actually true. This statement is actually true. But tell me a beautiful question I want to ask. If I remove this only if, so this statement number 4 is actually true. You can see. Look at this statement number 4. This statement number 4 is actually true. But in this statement number 4, if I remove this only, now what? Please understand. If I remove this only, this word only if I remove, now this statement is false. Now this statement is false. Okay, are you getting my point? I am saying that if you remove this only, then this is if. Now you tell me, is this true or false? So you notice that P if Q, what is that? That is Q implies P. Okay, so here this if basically means that this implies this. This implies this. Now this is false. Why this is false? Tell me, what is the reason this is false? This is false. What is the reason this is false? Can you tell me? Can you tell me why this is false? Time stamp is greater than read time stamp, then why it is false? Like this is your T. This is the transaction T. And this is some other transaction T dash. Let's assume this is the right operation it is doing. So if this at this point of time, let's assume at this point of time, transaction T time stamp is greater than read time stamp of X, then what is the problem? Can I say this will be successful? Can I say this will be successful? When it will be successful? A simple question I am asking. When it will be successful? When it will be successful? When it is going to be successful? It will be successful. Okay, it will be successful if and only if this happens. What happens? That this time stamp of T must be greater than read time stamp of X, and time stamp of T must be greater than write time stamp of X. So both must happen. Is this clear? Yes, very good. So remember this simple point I am telling you, that a simple point, this and is there. Means if you want this to be successful, so this is the situation that this T wants to, let's assume this T, it wants to write item X. Now this will be successful. When it will be successful? It will be successful if and only if, okay, this will be successful if and only if two things should happen. This transaction time stamp should be greater than the read time stamp of X, and also basically also the time stamp, this time stamp of T must be greater than write time stamp of X. So very simple. So this should happen. Okay, so when both of them will happen, then you can do it. Then you can do it. In this situation you can do it. So did you understand? A simple if and only if can change the statement. So for this particular question, I can say the answer will be this is true, and this is true. So the answer will be 3. 3 statements are correct. Okay, the answer is going to be 3. Total 3 statements are correct. But remember a simple thing, if you remove the only if, then this is false. Now this will become false. If you remove the only if, then it will become false. Okay, this statement number 4th, it will become false if you remove only if. Okay, let's move on. So this was your question number 32. Now, let's see. There is a Thomas Wright rule. What is this Thomas Wright rule? This we have already seen. Let me just quickly tell you. What is this Thomas Wright rule? What this Thomas Wright rule says. Okay, this Thomas Wright rule means TWR. Thomas Wright rule. What is this Thomas Wright rule? This is basically, this says that everything else is same as TSP. Only one case is changed. Okay, this Thomas Wright rule, it says this is about right. This is related to right rule. Means this is related to the right operation. What this rule says, this rule basically says that if you want to write operation like this T and there is this T dash, and let's assume you want to do the the write operation, and this has already done the read operation, then what we should do? Tell me, then what we should do? See, here there is no, here it will be same as your normal TSP. So here you will roll back. Okay, so here you will roll back T. Okay, so remember, here you will roll back T. Here you will roll back T because this is read-write conflict. Okay, so this read-write conflict, same as TSP. Same as TSP. Is this clear? This read-write conflict, it will be same as TSP. This Thomas Wright rule, it says that read-write conflict will be same as TSP. It will be same as TSP. The only change will happen when you have write-write conflict. When you have this write-write conflict, this is the only change. Okay, in this change, actually what happens? In this change, we ignore this T. We don't roll back here. Here we don't roll back. We just ignore this WX. Okay, no rollback. Ignore this. Ignore this WX. Don't roll back. Do not roll back. So don't roll back this T. Just ignore this WX. Ignore. It's like ignore and continue. Don't roll back. No rollbacking T. So we don't roll back T. No rollback T. Just ignore this. This will be ignored. It will be completely ignored. We will not perform this. It will be completely ignored. The reason we have already seen in the lecture. See, the reason is actually very simple. What is the reason? Let me tell you. Why we can ignore this? Because remember, in this order things should happen. Do you agree? Do you agree that in this order, conflict operations should happen? So in this order, if conflict operations should happen like T and T dash, in this order, if conflict operations should happen, and let's assume this is also doing the, this is what I'm saying. See what I'm saying. Understand this clearly. Let's assume this is also doing the write operation. This is also doing the write operation. In this order, the things should happen. This is the order of serializability. This is the order of serializability. Now you tell me, in this order, if things should happen, then what should be the final write of X? Who should do the final write of X? Tell me. This is the ideal. I can say this is the ideal order of conflict operations. So you tell me who will do the final write of X? Who is going to do the final write of X? So definitely this T dash will do the final write of X. So you can notice this is the final write of X. X by T dash. So anyway, this will be overwritten. Do you agree that anyway this will be overwritten? Do you agree that this will be overwritten by T dash? This will be overwritten by T dash. Yes or no? This operation, look at this operation, look at this operation by T, look at this. This will be overwritten by T dash. It will be overwritten by T dash. Okay. So if it is overwritten by T dash, final write will be done by T dash. Then what we can do, if T dash has already done write, then you just ignore this. See, if T dash has already done write, this T dash, this should this should reflect in the database, yes or no? Do you agree that this should reflect in the database? Should reflect in database. This should reflect in system, in database. This should reflect in the database. This should reflect in the database. So what you can do, just simply ignore this. Don't roll back. Just simply ignore this. Very simple. Very simple. That just simply ignore this. Don't roll back. Don't roll back. Just simply ignore this, because ultimately, if you ignore this, let me assume you just ignore this, then ultimately this will be reflected in the database, and this is what you want. This is what you want, that this tds write operation should be reflected in the database. This tds should do the write operation. The final write operation should be done by tds, and this is what you want, and this is happening. So that is perfectly fine. So just ignore this w. Just ignore this write operation. You ignore, and you continue the just continue. T continues. Okay, just ignore this and T continues. That's it. So this is your Thomas Wright rule. Very important thing I want to tell you in the Thomas Wright rule. This is very important thing, that this is very important. What is very important? In the Thomas Wright rule, remember, read write conflict is same as your TSP. So if you have this type of transaction, T dash. Okay, now you tell me, if I do write operation here and I do write operation here, then let's assume read operation here. Is this allowed by Thomas Wright rule? Is this allowed by Thomas Wright rule? Is this allowed by TSP? Is this allowed by Thomas Wright rule? Thomas Wright rule. Is this allowed by them? So definitely this is not allowed by TSP. You can clearly see that this is not allowed by TSP. Not allowed by TSP. So this is definitely not allowed by TSP. So there is no problem here. This is not allowed by TSP. But remember, this will be allowed. This will be allowed by Thomas Wright rule. Allowed by Thomas Wright rule. But this will not be allowed by Thomas Wright rule. Okay, this is not allowed by Thomas Wright rule. Is this clear? So this is not allowed by Thomas Wright rule. Ultimately here T will roll back. Ultimately here T will roll back. So this T will roll back here. This will be ignored. See, this will be ignored. This will be ignored, but here you will roll back. So this is an important point that I want to tell you. Many students will make mistake here. What they will do? They are so focused on this write. See, Thomas Wright rule, whenever some student will see this, that okay, Thomas Wright rule, immediately they will think about write. They do not think about this is not allowed. This is fine, but this is not allowed. Is this understood? That this is not allowed in the Thomas Wright rule. In the Thomas Wright rule, this is allowed. This is fine. This will be ignored. You will ignore this. But this is not fine. Is this clear to everyone? Very simple thing. So remember, Thomas Wright rule does not allow this. Like for example, you have read here, you have write here. This is not allowed. This is not allowed. Okay. Similarly, if you have, so very simple. So these are the points I want to tell you. As I told you, this write, this read, this is not allowed. Okay. So this is your Thomas Wright rule. Now let's see this question. Tell me the answer. Tell me the answer. Can I say Thomas Wright rule, TSP, timestamp protocol with Thomas Wright rule, it ensures conflict serializability? Can I say Thomas Wright rule, it ensures conflict serializability? It ensures conflict serializability? The answer will be no. Okay. Now this will not ensure conflict serializability. now it can generate non-conflict serializable schedule. For example, I can give you like T1, like T1, like T2, like T3. Consider this scenario that let's assume you are doing the read operation here, you are doing the write operation here. Let's assume this is the order. You are doing the write operation here and then you are doing the write operation here. So again, you cannot, this is not conflict serializable, yes or no? This schedule, if you notice, this is view serializable. You can check it out. We have already seen what is view serializable and how to check it. So this is view serializable. This is not conflict serializable. This is not conflict serializable, but this is allowed by TSP, Thomas Wright rule. This is allowed by Thomas Wright rule. So you can note this is allowed by Thomas Wright rule. This is allowed by Thomas Wright rule. Okay, it will be allowed by Thomas Wright rule. It will be ignored. We will basically ignore this. It will be ignored. So Thomas Wright rule will allow this. Is this clear? Thomas Wright, this will be allowed. But remember, this is allowed by Thomas Wright rule, but this is not conflict serializable. This is not conflict serializable, but still this is allowed by Thomas Wright rule. So ultimately, can I say, tell me, can I say Thomas Wright rule ensures conflict serializability? Can I say Thomas Wright rule will guarantee conflict serializability? Using Thomas Wright rule, can I say only conflict serializable schedule will be generated? The answer is no. Using Thomas Wright rule, non-conflict serializable schedule also can be generated. Okay, using Thomas Wright rule. So this is a note that using Thomas, this is not allowed by TSP. Remember, this is not allowed by TSP because here you will roll back. Okay, here T1 rollbacks. So this is not allowed by TSP. By the TSP, by the timestamp protocol, it is not allowed, but it is allowed by Thomas Wright rule. Okay, by Thomas Wright rule, it will be allowed. It is non-conflict serializable. So again, I am telling you, you can notice if you have TSP, if you have this TSP, this timestamp protocol, this TSP generates only conflict serializable schedules. Conflict serializable schedules. Okay. So this TSP, it will only generate conflict serializable schedules. This statement is correct. It will generate only conflict serializable schedules. So it's like this. These are all the conflict serializable schedules. These are all conflict serializable schedules. This is what TSP will generate. Okay. So whatever TSP will generate will be conflict serializable. Remember, there are some conflict serializable schedules TSP cannot generate. Can you give me one example of conflict serializable schedule which is TSP cannot generate? One example. Can you give me one example of conflict serializable schedule not generated by TSP? Can you give me? Can you give me one conflict serializable, one example of conflict serializable schedule which is not allowed by TSP? Can you give me? Can you give me? Very, very, very easy. Very easy. A simple example you can take like this. Write item A, write item A. That's it. Or I can say write item A, read item A. That's it. So you can see this is conflict serializable, but this is not allowed by, not generated by TSP. It is not generated by TSP. Okay. This will not be allowed by TSP. So you cannot, this is not allowed by TSP. So you can see that this TSP will generate conflict serializable, but there are some conflict serializable schedules which are not generated by TSP. So TSP generates only conflict serializable schedules. Okay. And one more note. Using Thomas Wright rule, you can generate some schedules which are not conflict serializable. Okay. So I can say using Thomas Wright rule, we can generate, okay, using Thomas Wright rule, we can generate, we can allow or generate some non-conflict serializable schedules. Some non-conflict serializable schedules. Okay. So using this Thomas Wright rule, you can generate, you can allow some non-conflict serializable schedules. Non-conflict serializable schedules are also allowed. Okay. And you can generate some non-conflict serializable schedules which are view serializable. Some view serializable but non-conflict serializable schedules you can generate. Example we have already seen. Okay, the example we have already seen that using the Thomas Wright rule, what you can do, using this Thomas Wright rule, you can generate some view serializable but non-conflict serializable schedules. Okay, example you already know. Example is this T1, T2, T3. This is the read operation. This is the read operation, then this is the write operation. Then this is the write operation, this is the write operation. So this is the example. You can very easily see the example. So this will be ignored. Okay, so you can easily see that this is view serializable. This schedule on your screen, this schedule is view serializable, not conflict serializable, and this is allowed by by Thomas Wright rule. This is allowed by Thomas Wright rule. Tell me the answer for this question. Can you tell me quickly? Quickly tell me the answer for this question. Let me know. First, let me check what is this question number. Question number 33. Okay, so let's see this question number 34. Tell me the answer. Quickly tell me. This schedule is given to you. Which what are the possible values of P, Q? This is what we have to find. What are the possible values of P, Q for which the schedule is allowed by Thomas Wright rule but not by basic timestamp protocol? This is given that T2 has more timestamp than T1. Timestamp of T2 is more than timestamp of T1. Dipan is asking, what is the main objective of Thomas Wright rule? What extra feature it will provide? Thomas Wright rule will provide you more concurrency. Yes or no? See, Thomas Wright rule will provide you more concurrency. If schedule, see this Thomas Wright rule, this is the purpose. This Thomas Wright rule provides more concurrency. More concurrency than TSP. More concurrency it will provide. What it means? It means that if there is some schedule which is allowed by TSP, it is also allowed by, so it is, see, this is a note that if schedule is allowed, if the schedule S is allowed by TSP, if it is allowed by TSP, it will automatically be allowed by Thomas Wright rule. Okay, it will automatically be allowed by Thomas Wright rule. By Thomas Wright rule. So it is going to automatically be allowed by Thomas Wright rule. Okay. So if it is allowed by TSP, then it will be allowed by Thomas Wright rule. But some extra schedules will be allowed by Thomas Wright rule. This is not correct. Means Thomas Wright rule will give you some more concurrency. Better concurrency. Is this clear, Dipan? So for example, you can take this example T1, T2. A simple example you can take that this is write operation. This is write operation. You can see this schedule is not allowed by TSP. You can easily see this is not allowed by TSP. But this is allowed by Thomas Wright rule. This is allowed by Thomas Wright rule. Okay. So this Thomas Wright rule will give you more concurrency. More schedules are allowed. This is like this. Let me tell you. Like these are the Thomas Wright rule schedules. These are the Thomas Wright rule write rule schedules. Okay, these are superset of TSP. These are superset of TSP. So you can see that Thomas write rule will give you more concurrency. It will give you more concurrency. Dipan, is this clear? Tell me. Dipan, is your doubt clear? That Thomas write rule will give you more concurrency. Better concurrency it will give you. If schedule is allowed by TSP, it will also be allowed by Thomas write rule. So you can easily see that everything that is allowed by TSP is allowed by Thomas write rule, but Thomas write rule will give you more concurrency. Okay. Now let's see this question. Tell me the answer for this one. So let's check option A, WBWC. If I put WB here, if I put WC here, is this allowed by TSP? Is this allowed by TSP? Yes, this is allowed by TSP, right? Yes or no? So clearly this is allowed by TSP. Clearly this is allowed by TSP also. If it is allowed by TSP, it is automatically allowed by what? It is automatically allowed by what? It is automatically allowed by Thomas write rule. Yes or no? It is allowed by TSP, so it is automatically allowed by Thomas write rule. So this option is not correct, because this is saying but not allowed because of this. Okay, so this option is not correct. What about this WA? If I put WA here, now you can easily see this is not allowed by TSP. This is not allowed by TSP. This is not allowed by timestamp protocol. Is this allowed by Thomas write rule? This is also not the answer, because see this. This is not allowed by Thomas write rule also. Again, did I tell you that this is the most common mistake people do? Did I tell you people focus whenever you see this word Thomas write rule, your mind only goes here. Why are you forgetting this is not allowed? Thomas write rule, this is allowed, this is fine, but this is not allowed, right? Why are you forgetting this? So this is not allowed by Thomas write rule, by TSP, Thomas write rule. So this is also not correct. So the answer will be none of these. Answer is going to be none of these. Is this clear? Tell me. Ekta, SM, Dipan, is this clear? So the answer will be none of these, because this is not allowed. See, this is the right A. Look at this. You are doing right A. You are doing read A, right A. This is not allowed. So the answer will be option 4th. This is going to be the answer. So take care. Don't make this mistake. Again and again I am telling you. Before this question, did I tell you this point? Before this question, before you solving this question, I already told you this point. Still you are making mistake. Don't do that. Tell me the answer for this one quickly. Very quickly tell me the answer. Which action is taken by timestamp scheduler? Which action will be taken by timestamp scheduler? I am asking for a timestamp scheduler. Scheduler receives a request write X by transaction T, and this is given to you. This equation is given to you. That timestamp is greater than this and timestamp is greater than this. So tell me, means a request is coming from T. T wants to write, okay, this transaction T, it wants to write X. It wants to write X. This transaction T wants to write X. Okay, this transaction T, it wants to write X. And already it is saying that this transaction T is greater than, the timestamp is greater than this and greater than this. Then it should be allowed, yes or no? A timestamp of T is greater than read timestamp of X, and timestamp of T is greater than write timestamp of X. So definitely it will be allowed. In these two situations, this will be allowed. So what is the action taken by what action will be taken? The action will be allowed. Okay, this allowed action will be taken. Very simple, because already everything is perfect. Everything is perfect. There is no problem. So it will be allowed. What about this question? Question number 36. Thomas Wright rule. Now the same question with Thomas Wright rule. The same question with Thomas Wright rule. Again, this will be allowed. Again, this will be allowed. Because if it is allowed by TSP, it will be allowed by Thomas Wright rule. Yes or no? If it is allowed by TSP, if it is allowed by TSP, it is automatically allowed by Thomas Wright rule. Yes or no? So if it is allowed by TSP, then it is automatically allowed by Thomas Wright rule. So the same question with the Thomas Wright rule, it will be allowed. What is the next question? Tell me the answer for this one. What action will be taken? This is given. You want to write. Remember, you want to write. Transaction T wants to write. Now, the timestamp is greater than read timestamp, but timestamp is less than write timestamp. So again, this will not be allowed. Yes or no? So you have to T will roll back. This is the action. Action that will be taken is T will roll back. Correct? Here T will roll back because the question is saying that this T wants to write item X. But what the question is saying that this is perfect. There is no problem here. So this is perfect. But the question is saying that there is some other transaction has already written X. Has already written X. This is not allowed. This is not allowed by TSP. This will not be allowed by TSP. Yes or no? Will this be allowed by Thomas Wright rule? Consider this condition. This condition is given to you. This condition is given to you. There is no problem with the read operation. We don't have any problem with the read operation. We have no problem with the read operation. So read operation is perfect. With the Thomas Wright rule, what action will be taken with the Thomas Wright rule? The action will be taken is allowed. Okay, because there is no problem with the read operation. See, no problem with read operation. No read-write issue. So there is no read-write issue, but the issue is write-write. So this is allowed by Thomas Wright rule. So it will be allowed by Thomas Wright rule. Okay, is this clear? Because read the question. The question is saying that there is no issue with the read operation. Your transaction T timestamp is already greater than read timestamp of X. So there is no issue here. There is no issue here. No read-write issue. We have no read-write issue. But there is an issue with write operation. So that is allowed. There is no problem. So this will be ignored. Basically, this will be ignored. And you can do the computation. Okay, so remember here what will happen? What action will be taken? Let me, sorry, not allowed. You should not say allowed, you should say ignored. Ignored, but T not roll back. Sorry for that. So it will not be allowed, it will be roll back. Sorry, it will be ignored. Okay, is this clear what I'm saying? It will not be allowed, I can say this operation will be ignored. This operation will not be allowed. I can say this operation unsuccessful. This is still unsuccessful operation. Okay, this will be ignored, but the transaction will not roll back. So the operation will be ignored. Is this clear? Operation ignored, but the transaction is not roll back. We will not roll back the transaction. What about this question? Tell me the answer. Timestamp scheduler. You want to write X, but the timestamp, so basically this T wants to write X, but there is someone with more timestamp, has already read X. So definitely this is not allowed. Yes or no? Definitely this is not allowed by TSP. TSP does not allow it. And the same thing happens for, so here I can say TSP will not allow. So what action will be taken? What action is going to be taken? So T rollbacks. T will roll back. Okay. If the same question I ask you for Thomas Wright rule, then also the action will be taken is T rollbacks. Again the T rollbacks, because this is not allowed in Thomas Wright rule also. In Thomas Wright rule also this is not allowed. Okay. So these are the questions that we have seen. This is the summary you can read. This is a summary you can read. All these summary you can easily read. So tell me, did you understand everything that we have seen? Did you understand? Let me know. All the things that we have seen in this class, in this session, did you understand everything? Let me know. So this is your timestamp protocol. Can you say that you are expert of timestamp protocol now? Can you say this? Can you say that you are expert of timestamp protocol? Please tell me. Let me know. So did you did you understand this timestamp protocol in a crystal clear way? In a very crystal clear way. Did you understand this timestamp protocol? So should I ask you some questions? Or maybe we can see the remaining questions we can see in the, I can give you a quiz today. What we can do, I can give you the remaining questions, I can give you as a quiz. And then we can see the solutions in the next session. Okay, I can give you a quiz. This quiz you try, and then today it will be uploaded. Okay, on the GATEOverflow website, this will be uploaded. So you try this quiz, and then we will see the solution of this quiz. Okay, the solutions we will see live. We will see solutions again on live on GoClasses YouTube channel. On GoClasses YouTube channel. Okay, so a quiz I will give you from my side. Basically everything, every concept, every point, every variation in timestamp protocol is over. I hope you understood. Can you visualize the timestamp protocol now? In the GATE exam, if any question comes from timestamp protocol, are you confident that you will be able to solve? Are you confident that you will be able to solve whatever question comes in the GATE exam from this protocol, from this timestamp protocol, whatever variation, whatever standard question comes, you will be able to solve? Okay, so this is your timestamp protocol. I hope you understood. If you understood, please comment on the video. Okay, so please comment if you understood. If you understood, how much you understood, and what was your favorite part, what was your favorite question, basically your review. If you understood, then please comment. Okay, on this video, you please comment your review. So today this quiz will be uploaded on this quiz on GATEOverflow website. On GATEOverflow website. On the GATEOverflow website. Remember, not on the GoClasses website. On the GATEOverflow website. This quiz will be uploaded. It will be free in the exam section. It is free and you can try this. Solutions we will discuss live in the next session. Tomorrow we can discuss. Okay. So thank you everyone. See you tomorrow. So please like and comment this session. Whatever you understood, I hope you understood everything. So please like and comment. Okay, thank you. Bye.